A galaxy turns in the dark like a slow river, and the eye relaxes because nothing seems rushed. The Milky Way appears as a pale band in the night, a soft seam between horizons, a quiet that belongs to the oldest memories of Earth. In that hush, every star is a glint on water, and the current beneath is time itself. He looks at this river from a small planet and senses a peace that is not the absence of motion, but the mastery of it. A spiral unfurls with patience. Patterns repeat without urgency. The cosmos speaks in long sentences, and the Milky Way answers with an even longer breath. Inside this band, gravity does the simplest thing, and the simplest thing becomes beautiful. Mass gathers, light follows, and orbits find their paths, as if guided by a musician who prefers rests to crescendos. The disk turns, not as a rigid wheel, but as a patient conversation between inner and outer regions. Clocks here do not shout, they whisper in units of hundreds of millions of years. To a human life, this is frozen stillness. To a star, it is a comfortable pace that keeps collisions rare and allows neighborhoods to remain familiar across eras. The calm is statistical. The peace is an average taken over a multitude of tiny decisions made by gravity and motion. From a vantage point under rural skies, the human eye cannot resolve the grand design, yet the body feels it. The faint haze holds billions of suns, but the glow falls softly, cushioned by dust that scatters the harshness away. That same dust, forged in the depths of ancient stars, now cools and quiets the light of their descendants. Calm emerges from the cycle. The galaxy recycles violence into velvet. Supernovae once tore cavities through gas, yet later those cavities collapsed into new nurseries that now shine as gentle beacons. The record of upheaval becomes the fabric of tranquility. Silence in the night is not a silence of events, it is a silence of balance. The Milky Way's center rests far beyond bare sight, yet its influence feels like the slow heartbeat of a sleeping giant. A supermassive presence binds the innermost orbits with a patient hand. Stars near that heart race on razor paths, but the pattern as a whole remains stable, like a whirl of leaves that still forms a circle in the pond. Farther out, where he and his world drift, speeds even out. There is motion everywhere and pressure nowhere. The rotation curve that once puzzled astronomers now feels like a lullaby. It lifts the outer disk and refuses to let it fall. This is how a galaxy hums. In the spiral arms, star birth proceeds in a rhythm that resembles breathing. Gas gathers, stars ignite, winds push, and the medium rests before the next inhale. The arms are not conveyor belts. They are traveling harmonies, passing through the disk and coaxing gas to shine without dragging every star along. The theater is full and the stagehands are invisible. He would search for alarms and find instead a choreography of causes and effects that cancel into poise. Even the occasional flash of a nova becomes an accent rather than a rupture, a spark that reminds the eye of the fire from which serenity is forged. The sensation of calm intensifies with scale. A single star can flare, a region can surge, a bar can torque the inner orbits, and a cloud can collapse into a jewel of blue. Yet the larger he imagines the frame, the more the turbulence dissolves. On the width of the disk, asymmetries blur into wreaths of light. On the height of the thickened layers, the scars of long-past mergers become a soft, older glow. Out in the halo, where stars travel on wide, patient ellipses, the galaxy keeps the memory of formation as a low murmur, a whisper that never turns to a shout. Beauty arises because differences spread across distances and timescales so wide that no single disturbance can dominate the view. The Sun's neighborhood offers a tactile example of how serenity works. Stellar densities are modest. Typical separations are measured in light years, a spacing that makes catastrophe improbable. Encounters happen, but most are glances. Tides graze comet clouds and then pass on. The planets keep their lanes because nearby stars are more like distant lighthouses than traffic. The night sky's patterns are so stable that ancient farmers could tie harvest to them and sailors could find their way across oceans. The reliability of that dome is a direct gift of galactic calm. It is not silence imposed from above. It is silence built from countless small agreements. Look at the color of the Milky Way, and a second kind of relaxation appears. The integrated light is peaked toward the yellow of mature stars. Such stars are steady companions. Their fuel burns with restraint, their variability is modest, their lifetimes run long. The galaxy contains hot blue beacons and ruby supergiants, but the chorus that fills most of the band belongs to middle-aged suns, and they sing a slow song. Their numbers overwhelm the outliers. Their patience defines the hue of the river. Even the intervals mark a gentleness. A spiral arm passage for a star like the Sun takes on the order of tens of millions of years. The revolution around the center asks for a few 100 million more. The entire life of a mammal species may pass between subtle shifts in the local stellar climate. Evolution can unfurl in the same patch of space without being jostled into extinction by a neighbor. The galaxy does not guarantee safety, but it offers long seasons in which life can cultivate meaning. That is a quiet gift, and it arrives because the grand structure dampens its own extremes. Consider the geometry. A thin disk spreads mass in a plane, reducing the sharpness of gravitational gradients and encouraging near-circular motion. The orbits that deviate feel gentle corrections that bring them back into a family of paths. The mathematics is austere, but the image it paints is tender. Circles within circles, each slightly oval, each slightly influenced by the rest, all contributing to a shape that rarely shocks itself. A spiral pattern superposed on this disk does not scramble the picture, it modulates it, like ripples gliding over a larger current. The interstellar medium, far from empty, diffuses anxiety by distributing energy through phases. Warm gas, cold clouds, and hot bubbles trade heat and momentum. Turbulence cascades from large eddies to finer ones where it finally dissipates. Feedback opens a window, and then the window closes. The average conditions drift toward equilibrium, and stars form at a rate that neither exhausts the gas nor allows it to stagnate. The outcome is a galaxy that looks, in integrated light, like a single calm sigh. Beyond sight, an invisible framework steadies the scene. Mass that does not shine steadies the rotation and cushions the disk against its own restless tendencies. It is a quiet architecture, not seen, not touched, but inferred from the way the galaxy refuses to fly apart. He stands under the Milky Way and feels the security of that unknown support, the way a bridge feels safe even when the river is swollen. The unknown can be frightening, but here it becomes a reassurance. The mystery bears weight, and the weight becomes poise. At the edge of vision, the band thins. The eye has adapted to the dark, and the world around him has faded until the galaxy appears to hover as a separate sky. He can imagine traveling up and out, past the plane and into the sparse halo, watching the river of stars beneath him stretch into a luminous map. From there, the sense of calm would deepen again. The disk would gleam like a brushed ring of silver. The arms would appear as faint, drifting weather. The core would pulse with a subdued glow. The whole would look suspended, as if held in place by a promise. Calm is not an illusion. It is a perspective tuned to the right scale. The Milky Way teaches that lesson by simply existing. It brings together gas, dust, stars, remnants, and the unseen into a system that survives time by distributing motion wisely. It is not a poem. It is physics arranged so gracefully that it feels like one. He listens to it without ears, through the skin of the night and the patience of his own breath. He learns that serenity can come from many voices, speaking softly at once. He learns that stillness can be a function of size. He learns that a river can rush and still look like glass. He watches a map appear where once there was only a band of light. The first cartographer holds a small telescope and vast patience. In the late 18th century, William Herschel counts stars by the thousands and sketches a disk that looks like a grindstone. He places the sun not far from the center because dust is still an unspoken character in the play. The drawing is wrong in its details and right in its ambition. It teaches that a galaxy can be charted by adding up its tiny lights. The lesson stays. Time moves and the technique shifts. In 1918, Harlow Shapley gathers globular clusters into a pattern no one had fully seen. These ancient swarms encircle the true center, and their distribution points toward Sagittarius. The sun finds itself exiled from pride of place. A new scale enters the conversation. one that stretches tens of thousands of light years and refuses to bend to human preference. The center is far, and the Milky Way is a system with a structure larger than intuition. The map deepens. A quiet correction arrives, with a Swiss-born observer under California skies. In 1930, Robert Trumpler proves that interstellar dust dims and reddens starlight. The darkness is not emptiness. It is a curtain that misled early counts. With that correction, the disk grows broader, the distances lengthen, and the errors of nearness fall away. Astronomy learns to subtract what the medium steals, and the cartography becomes honest. It is a victory of method over assumption. Rotational clues collect in the decades that follow. Bertil Lindblad proposes a differential turn for the stellar system, and Jan Oort frames the local shear with constants that enter textbooks like quiet metronomes. The disk does not pivot like a solid wheel. It drifts with inner parts leading and outer parts lagging, a behavior that marks a vast collective bound by gravity rather than by rigidity. Kinematics becomes a language, and the map gains arrows, not just dots. The most transformative ink is radio. In the early 1950 seconds, observers tuned to the 21-centimeter line of neutral hydrogen, a frequency emitted by the spin flip of an electron bound to a proton. Suddenly, the Milky Way can be traced through its own dust, because radio waves slip through what stops light. Dutch and Australian teams draft longitude velocity diagrams that bloom into spiral features. The International Astronomical Union defines galactic coordinates so that every future atlas will speak the same dialect. The plane of the disk receives a grid, and structure steps forward with modest confidence. Molecules enter next, especially carbon monoxide, whose glow reveals cold clouds where stars will form. In the 1970 seconds and 1980 seconds, surveys trace lanes of dense gas curling through the inner regions. The arms are no longer just starlight. They are weather patterns of chemistry, pressure, and gravity, all sketched in emission that does not blink with atmospheric seeing. A blueprint accumulates for the cycle of birth and feedback. The atlas acquires layers. Infrared eyes open above the atmosphere. In 1983, IRAS drifts around Earth and unveils the dusty spine of the disk with an intimacy that optical surveys could only suggest. COBE follows, measuring the smooth glow of old stars in the bulge and hinting at an asymmetric heart. 2-micron all-sky survey takes the baton in the late 1990 seconds, delivering a near-infrared portrait of the entire sky with a clarity that makes bar-like structure a practical conclusion. The central light is not round. It is a stretched lantern, and the inner orbits likely follow that elongation. The map, once a flat sketch, begins to feel sculptural. Precision in distance turns from hope to practice. The European mission Hipparcos measures parallaxes for stars close enough to show a yearly wobble against the far background. Those angles, minuscule and stubborn, secure the base of the cosmic distance ladder. With solid nearby anchors, standard candles such as Cepheids and RR Lyrae can be calibrated with less anxiety. Their pulsations, linked to luminosity, extend the ruler deep into the disk and out toward the halo. Star clusters, nebulae, and spiral segments migrate from guesswork to measured positions. The halo reveals its threads when digital cameras and wide-field surveys become routine. In the 1990 seconds and 2000s, astronomers trace the long stream of the Sagittarius dwarf galaxy, a torn ribbon arcing around the Milky Way. Other streams appear, delicate as frost on glass. These are not merely curiosities. They are tracers of the gravitational potential, the way scattered leaves can sketch the wind around a building. The outskirts acquire edges not as walls but as gradients where the density of belonging fades into the intergalactic quiet. The map grows a margin. Bulge microlensing surveys stare for years at crowded star fields and catch brief brightening when unseen masses pass in front of distant sources. The technique confirms dense populations and refined structure in the inner regions where confusion reigns. Red clump giants, acting as standard crayons of brightness, draw the X-shaped pattern that emerges from overlapping orbits. The central geometry, once a blur, turns into a vault with timbers set at elegant angles. The atlas now contains architecture. Spectroscopic cartography adds chemistry to position and motion. Projects that collect millions of stellar spectra measure iron, alpha elements, odd traces that tell of past supernovae, and the timescales of enrichment. The disk sorts itself into thin and thick components, the former younger and cooler, the latter older and puffed up by a history of heat and stirring. The city gains neighborhoods with biographies. The map folds into a chronicle, and stellar populations become paragraphs in a long narrative. A new era arrives when a spacecraft begins to chart positions and motions for more than 1 billion stars with exquisite precision. Proper motions turn into rivers on a plane. Parallaxes refine distances to a level once unimaginable. The disk shows ripples as if a stone had grazed its surface. Spiral structure is inferred not only from light, but from the streaming of stars through patterns. Warp and flare, once whispered about in specialist rooms, are traced as graceful deformations of an enormous sheet. The Milky Way is no longer a backdrop. It is a dynamic field recorded in 6 dimensions of phase space. Computations rise to meet the data. Simulations of galactic disks embedded in invisible halos reproduce bars, arms, warps, and corrugations from first principles. Observers and modelers begin to speak a shared language, comparing pattern speeds, resonance radii, and the contrast of arm segments. The map now includes timetables, intervals for how long certain structures persist and how quickly they drift. The atlas has become a timepiece. Small questions refine the grand picture. How far is the sun from the center in light years to the first significant digit? How thick is the thin disk near the solar circle? How much does the warp pull the outer plane above and below the midline? Each answer narrows the error bars and aligns the scales on different instruments. The result is a home address, written with coordinates, velocities, and chemical tags rather than street names. The cartography reaches outward into dark matter by inference. Tidal debris, the motions of satellite galaxies, and the escape speed of high-velocity stars all outline a mass distribution that stars alone cannot account for. The halo is sketched not by glow but by the way it bends the paths of travelers. The edge is not a cliff. It is a region where gravitational influence dwindles and the reach of the galaxy cedes space to the general pull of the cosmos. The map respects that diffuse frontier by shading rather than drawing a hard boundary. He looks at the resulting portrait and recognizes calm in the very act of measurement. Deeper surveys did not reveal a tangle beyond comprehension. They revealed patterns that widen gently as scales increase. The tools multiplied, yet the diagrams converged. Star counts, variable stars, radio lines, infrared luminosities, parallaxes, proper motions, and spectra all described a system that can be navigated without haste. The chart on the table is a meditation, the record of generations who added one clear layer after another until a galaxy became a knowable dwelling. The inner light of the galaxy carries a quiet secret. Beneath the rounded glow sits a long stellar structure that turns with patience, a bar of stars and dark mass that guides the inner traffic. Infrared eyes made the shape obvious, but the pattern was always there, a lantern stretched across the core. Its geometry is not a solid rod. It is a region where stellar paths align to support an elongated potential, a collective decision written in orbits. The result is an engine that runs without noise, a slow rotor setting the tempo for the inner tens of thousands of light years. 2 main families of orbits underpin this form. One set stretches along the bar, with stars lingering near the ends, before sweeping back through the center. Another set sits perpendicular nearer to the core, weaving a cross-hatched skeleton that keeps the whole figure from collapsing. These paths are not random. They are guided by a gentle difference in gravity along one axis compared with the other, a mild asymmetry that persuades stars to return to the same lanes again and again. From a great distance, the bar looks like glow. Up close, it is choreography. Gas feels this geometry in a different way. Clouds respond to pressure and shocks as well as to gravity, so they stream inward along the leading edges of the bar. There they form dust lanes that appear as dark rivers in some images and as bright stripes in radio and infrared maps. The flow is not a headlong rush. It is a controlled delivery that carries material toward the core where it can settle into a compact ring and ignite star formation. The inner few hundred parsecs become a lapping shoreline of molecular clouds and newborn clusters, a calm harbor fed by a stately current. The bar turns more slowly than the inner star's orbit. This difference creates resonances where a star meets the same tug repeatedly at the same orbital phase. At corrotation, the pattern and a typical star circle the center at matching angular speed so that the bar appears nearly fixed in that star's rotating frame. At inner resonances and outer ones, the repeated nudge shapes, rings and gaps that have been mapped across the disk. Nothing explodes at a resonance. Instead, order emerges. Angular momentum drifts outward along quiet channels. Material inside tends to give, material outside tends to receive, and the disk rearranges itself in a way that reduces chaos. The bar's rotation and its length are not arbitrary. They settle into values that allow corrotation to sit just beyond the bar's tips, a configuration that sustains the structure for a long time. If the bar were too fast, stars would be flung out of alignment. If it were too slow, new orbits would not lock in. The system finds a compromise that keeps orbits loyal and prevents abrupt transitions. This is a form of self-regulation. The galaxy listens to its own dynamics and chooses a rate that maintains a graceful silhouette. A curious consequence of the bar's long life is the shape of the bright central swelling that envelops it. To an external telescope, the bulge looks boxy when seen edge-on, sometimes even X-shaped. This is not a separate body wedged into the middle. It is a vertical puffing produced when the bar buckles and then settles, lifting stars above and below the plane in a symmetric fold. The effect is architectural. The city core acquires buttresses that distribute stress and enhance stability. The eye reads strength. The dynamics deliver it. The influence of the bar reaches far beyond its visible ends. It sends waves into the disk that can seed or strengthen spiral arms. In some regions, it creates rings aligned with its major or minor axis, fossil ripples of resonant shaping. In the solar neighborhood, careful measurements have hinted at subtle streams in velocity space, clumps of stars sharing similar motions, as if the bar's rhythm had tapped out a pattern even at this distance. Those patterns do not disrupt, they organize. Local orbits become slightly more oval, guiding the flow of stars without erasing the overall circular calm. Star formation near the bar shows another kind of moderation. Gas on its inward journey can be compressed along shocks, but the rate of delivery smooths the bursts. A nuclear ring forms where gravity and rotation balance, and there the tempo is measured. Clusters appear in arcs and slowly age as they drift along the ring's curve. Energetic feedback from these clusters vents into the surrounding medium, yet rarely ruptures the structure that fed them. The system breathes without panting. The light it emits in infrared and radio rises and falls like a tide rather than in spikes. The central black hole sits inside this arrangement with quiet dignity. It is not a drain that empties the bar. It is a compact anchor around which the innermost orbits whirl. Gas may reach the immediate neighborhood of the hole through further instabilities or by small non-axis symmetric ripples within the ring, but the bar itself is a mediator rather than a reckless funnel. On cosmic timescales, the inflow that ultimately feeds the black hole is intermittent and modest, allowing the central engine to slumber between brief feasts. The large structure protects the small by pacing the supply. Chemistry records the bar's work. The inner disk shows gradients in metallicity that flatten over time as the bar mixes material across radii. Stars born in regions that were once chemically distinct find themselves stirred into a common annulus. The palette becomes more even, and with uniformity comes predictable evolution. The gradient does not vanish entirely, but it relaxes. Calm appears even in the periodic table as abundances smear into smooth functions of distance from the center. A bar can evolve, it can grow longer as it exchanges angular momentum with the outer disk and the dark halo. It can slow gently as it hands off that momentum. It can buckle and then thicken, strengthening its vertical structure. Each change happens over hundreds of millions of years. Each leaves the system more coherent than before, Rather than tearing the galaxy, these slow processes knit it. The bar's history becomes a story of consolidation, not of fracture. Observation and simulation agree that such structures are common among spiral galaxies. The Milky Way's version is neither the largest nor the smallest, neither the fastest nor the slowest. It belongs to a majority class in which bars serve as managers of internal evolution. The presence of a bar correlates with certain rings, with specific distributions of gas, with a particular efficiency of moving matter inward without chaos. His home galaxy participates in this quiet generality. Normality can be soothing when the scale is this grand. The sense of serenity arises from how many problems the bar solves at once. It channels gas without explosions. It supports the bulge without a separate violent event. It seeds arm structure without excessive shears. It mediates the exchange between disk and halo so that energy and angular momentum flow along orderly corridors. Each of these tasks happens in parallel, yet they do not clash. The figure in the center acts as a conductor who keeps different sections in balance. Even the view from inside can be read as reassurance. Star counts toward the core reveal an elongated distribution of red clump giants that astronomers have used to map the bar's angle relative to the line from the Sun to the center. Different longitudes light up at slightly different distances, drawing a tilted ridge across the data. That tilt is a sign of coherence. A structural feature maintains its orientation across thousands of light years and announces itself in the most ordinary traces. The galaxy does not hide its framework. It reveals it in plain statistics. The long-term outcome of a bar is a disk that ages gracefully. Material migrates inward to sustain moderate star formation, where resources are abundant, and outward to prevent pileups that would destabilize the outskirts. The bulge strengthens and settles. The spiral pattern finds consistent support. The inner halo absorbs what it must and responds with only slow shifts in shape. The scene suggests longevity without stagnation. Everything circulates. Little collides. The tranquil fact is that a single asymmetric component can make a complex system feel composed. The bar is not a scar. It is a spine. It allows the galaxy to carry weight without strain, to change without trembling. Under its influence, the Milky Way presents a face that is neither austere nor fussy, a face that invites long looks and rewards them with subtle order. He studies that glow and senses reassurance in its steady turn, a reminder that even in the crowded heart of a galaxy, calm can be engineered by gravity and sustained by time. He imagines a hand placed gently upon the disk, not to push but to guide. Spiral arms appear where gravity persuades rather than insists. They are not solid bridges. They are regions where orbits crowd for a while before thinning again, like cars slowing through a scenic bend without stopping. The pattern moves with its own pace. Stars and gas drift in and out, joining the luminous ribbons for a time, then continuing on with nearly circular grace. The quiet comes from this difference between matter and motif. The arms are a song that passes through the choir rather than a line of singers marching in lockstep. Light gives the arms their first outline. Young stars, hot and short-lived, outline the crests with blue splendor. They reveal where gas met a gentle compression and ignited within a few million years. Yet most of the mass belongs to older suns that barely notice the pressure. They glide through the pattern in near-circular paths. That is the paradox that steadies the scene. The arm looks like a conveyor of stars, yet it is more like a traveling sound wave in a meadow of grains. The meadow sways, the sound moves on. Gas responds with more feeling. As it enters an arm, its speed relative to the pattern shifts. A subtle crowding develops. Clouds brush one another, magnetic fields thread and tighten, and shocks form along the inner edges. Dust lanes mark the compression, dark strokes that run just upstream of the bright star clusters. The sequence is a lullaby of cause and effect. Gas compresses, star formation triggers, massive stars light up, and their winds and supernovae push the medium onward. The arm inherits a profile where dust, young stars, and older populations lie in repeated, offset lanes. The order calms the eye. Effects keep their respectful distance from causes. Pattern speed frames the rhythm. Interior to a special radius called corrotation, Stars orbit faster than the spiral pattern, so they overtake the crest from behind and exit on the far side. Outside that radius, the pattern moves ahead of typical stars, and the flow reverses. At corrotation itself, matter and motif circle with the same angular pace. There, crowded orbits linger longer, and resonances shape rings and gaps that can be traced in the positions and motions of countless suns. The galaxy self organizes through these resonant exchanges. Nothing breaks. Paths are massaged into families that repeat. Pitch angle adds a kind of visual temperament. Tighter arms wrap close to the center, while looser arms open wide to the outskirts. This angle correlates with the central mass and the rotation curve, a quiet link between large-scale gravity and visible design. Stronger shear tends to wind arms more tightly, yet the pattern resists becoming a spiral of string. Density waves grow, saturate, and then fade, replaced by fresh ripples seeded by bars, by encounters with small satellites, or by the self-gravity of the disk itself. The mixture of triggers creates arms that appear persistent when averaged across time, even though their individual segments are living, changing things. Some galaxies display two grand, sweeping arms that dominate the face. Others show many fragments, a flocculent bloom of shorter pieces that connect and separate, like cloud streets. The Milky Way balances between these extremes. Near the center, stronger drivers shape prominent lanes. Farther out, segments and spurs decorate the disk with a lace of star forming regions and dust. The continuity felt by an observer arises from perspective and from the human gift for seeing patterns across gaps. The underlying mechanics accepts both unity and plurality. Calm survives in either case, because the arms never demand that matter stay put. Kinematics records the passage. As stars cross an arm, their velocities adjust by small amounts. These changes create streaming motions that can be measured along lines of sight and along the plane. The inflow toward the crest and the outflow after it leave signatures in velocity space. When mapped, those signatures resemble gentle eddies superimposed on the wider circular river. They are strong enough to trace, yet weak enough to leave orbits nearly circular over long spans of time. The result is traffic that regulates itself without patrols. Each passerby yields a fraction of speed here, gains it back there, and the average remains courteous. Magnetic fields thread the arms and act as quiet organizers. Compression amplifies the field along the dust lanes, aligning fibers of gas and guiding charged particles. Radio maps glow with synchrotron emission from cosmic ray electrons spiraling along those lines. The field also cushions the shocks, spreading stress across wider areas and delaying fragmentation. The effect is the difference between a rope that snaps and a braid that stretches. Star formation proceeds, but the rate is moderated by the tension in invisible lines that absorb and redistribute momentum. Clusters born in the crest's age as they drift. Downstream from dust lanes, one finds blue stars and H2 regions. A little farther, one finds clusters a shade older, their light softening toward white and then yellow. Still farther, the associations dissolve and leave the field star population enriched. The arm becomes a timeline written along its length. The progression repeats around the galaxy, not identically, but with enough consistency to let astronomers read a clock from the offsets. The result is a self-paced nursery, where bursts are rare and seasons are long. Spurs and feathers extend from the arms into the interarm spaces. These features arise where shear and feedback combine to draw filaments away from the main lanes. They look like brushstrokes painted by the disk as it turns. Far from being signs of disorder, they relieve the arms of pressure by letting gas escape before crowding would grow too intense. Flow through a living forest finds side channels. So does flow through a spiral disk. The safety valves keep the system from clumping into extremes. In the outer regions, the arms weaken and blend with the warp and flare of the disk. There, the gas layer thickens slightly, and the spiral pattern becomes more suggestive than commanding. Yet even at the edge, the pattern's speed and the rotation curve conspire to maintain a gentle contrast between arm and interarm. Star formation continues at a lower pace, and the ultraviolet glow of young groups lingers in small knots along faint, trailing lines. The serenity deepens with radius because the scale lengthens and the density falls. Noise fades into the general hush. Theories that treat arms as quasi-stationary density waves sit alongside models where arms are recurrent, transient patterns. Both schools find comfort in the observation that large-scale chaos does not emerge. Whether driven by a steady bar, by self-organizing fluctuations, or by tidal nudges from passing companions, the arms appear, strengthen, drift, and fade in an overlapping sequence. The eye perceives a stable design because at any given time enough segments align to produce sweeping lanes. The disc preserves rotational symmetry on average while wearing asymmetry as decoration. Measurement techniques add clarity without breaking the spell. Maser spots in star-forming regions give precise distances and motions that anchor the geometry of nearby arm segments. Parallax measurements for clusters and associations place luminous knots with accuracy that turns conjecture into map-making. Spectroscopic surveys reveal chemical gradients along and across the arms, showing where material has mixed and where it retains local history. Every dataset reduces the temptation to invent drama. The arms are dynamic, but not capricious. Feedback from young stars and their remnants acts as the metronome that keeps growth from running away. Ionizing radiation heats surrounding gas. Winds excavate cavities, and supernovae stir turbulence that spreads energy over many scales. The net effect is not to destroy the arms, but to prevent them from collapsing into singular lines. Pressure keeps gas from piling too high. Turbulence seeds the next generation of clouds, without letting any one region steal the entire supply. The pattern and the process respect each other. He studies the imagined face of this galaxy and finds that the most relaxing truth lies in the distinction between structure and substance. The spiral is a rule, not a chain. It invites participation without binding anyone indefinitely. It offers a stage on which stars are born and then lets them step into the broader ensemble. What could be more calming than a design that works by letting go? The arms guide, then release. They mark the path, then fade behind the traveler. In this way, a rotating disc becomes a landscape of gracious passages, a place where motion is everywhere and urgency is nowhere. He looks for collisions and finds absence. Stars pass within light years of one another, blink, and continue. The galaxy behaves like a fluid without drops touching. The distances are so large that direct encounters almost never change a stellar path. That scarcity is the origin of calm. The orbits adjust not by bumping, but by sharing a common field that spans the whole system. Gravity acts as a smooth medium. Motion answers to the average, not to the nearest neighbor. Classical relaxation by two-body scattering would require times longer than the age of the universe for a disk of this size and density. A star would need to wait through more time than time available for nearby masses to jostle it into a new direction. That calculation liberates the mind from the image of a crowded street. The Milky Way is closer to a school of fish with wide spacing, responding to the water rather than to fish against fish. The potential is the water. Each orbit knows it, and most orbits know little else. Yet there is another kind of relaxation, one that operates without collisions. Consider phase mixing. Imagine a set of stars that begin with similar phases on their epicycles, the small radial oscillations that ride on their near-circular paths. Their frequencies differ slightly because orbital speed and epicyclic rate shift with radius. Over time, the phases spread and wrap around the circle. What began as a clump becomes a ring, then a smooth band. The density evens out without a single encounter. Order emerges from the sum of tiny differences, not from impacts. Another process works during times of rapid change. When a global potential shifts quickly compared with orbital periods, energies can redistribute coherently. This is called violent relaxation, though the name hides more drama than the outcome. It is efficient in a forming halo or a young bulge, where gravity deepens as material collapses. The result is not perpetual turbulence. It is a quick march toward a stable distribution function that depends on integrals of motion, usually energy and components of angular momentum. After the sprint, the system rests. Calm arrives because the large changes have already found their balance. Away from such fast eras, The collisionless Boltzmann equation and its implication, Liouville's theorem, rule the evolution in the quiet. The theorem states that the density of phase space along an orbit remains constant. In practice, this means a group of stars stretches and folds like dough without tearing. Streams, filament, and wind, but the total occupation of their fine threads does not clump into spikes. Observers see a smooth background because instruments average over unresolved strands. The hidden texture becomes tranquility to human eyes. Mathematics turns into mood. Orbits in a near axisymmetric potential can be described by 3 actions and 3 angles. Actions are conserved quantities for regular motion. They measure the amplitudes of radial, vertical, and azimuthal oscillations. Angles wind at rates given by frequencies. This language simplifies the idea of serenity. If actions change only slowly, then orbital families persist for billions of years. The disk is a collection of these families, each with a little epicycle in the plane and a little bounce above and below it. The epicycle makes a star wobble around a guiding center. The bounce sets the thickness of the stellar layer. The guiding center itself rides a near-circular path. 3 movements, none hurried, produce an ensemble that looks still. Noise does exist, but it comes from broad structures, not from random knocks. Spiral patterns and bars, passing satellite galaxies, and giant molecular clouds can all nudge actions. The changes fall into 2 categories, often called blurring and churning. Blurring increases the amplitude of radial excursions and the height of vertical bounces. Churning shifts the guiding radius without increasing epicyclic energy, a trade of angular momentum at corrotation. Both processes rearrange without wreckage. A star drifts to a new address, then settles into the local traffic. Chemical gradients soften as migrants mix, yet the kinematic order holds. Velocity dispersions tell the thermal story of this city of orbits. In the plane, random speeds have 2 principal components, radial and tangential. Perpendicular to the plane, a 3rd component measures how strongly stars scatter from the midline. Younger populations exhibit smaller dispersions. Older ones are warmer, puffed up by long exposure to spiral arms, bars, and irregularities. The increase is gentle. A few tens of kilometers per second accumulate over billions of years. The disk thickens, but it does not overturn. The difference between a thin and a thick layer is not a wall. It is a soft quilt sewn by time. Stability has a criterion, distilled into a parameter that compares self-gravity to shear and pressure. When this parameter rises above a threshold, widespread collapse is suppressed. The average disk maintains values near or above that line over large regions, especially in stars. Gas lives closer to instability, since it can cool and compress. Even there, feedback from young stars and turbulence keep the system near marginality, where structures form, but global failure does not occur. The disk rings like a drumhead, tuned to a pitch that avoids tear or slack. Regular and chaotic orbits coexist, particularly where asymmetries are strong. In a nearly smooth field, tubes and boxes in 3 dimensions, or near circular and epicyclic paths in 2, dominate. Add a bar or a warp, and some trajectories wander through chaotic seas on long timescales. Even then, the diffusion is slow. It is measured in billions of years. Dynamical maps resemble wood grain. The regular islands occupy most of the space, veins of chaos weave between them, and the pattern holds the piece together. Serenity survives because the chaos is reluctant rather than ravenous. Kinematic substructures offer an intimate view of these processes. Groups of stars share similar velocities that reflect resonances with large patterns. Such groups are not clusters torn from a nursery and still bound by youth. They are ensembles created by the way the potential guides motion at certain frequencies. The beauty is that these ridges and branches in velocity space persist across age and composition. The signal comes from dynamics, not genealogy. The consequence is reassuring. The galaxy orders the flock by the paths they take, not by who was born next to whom. The scarcity of direct encounters has another gift. Planetary systems can live out their histories without frequent stellar disruptions. A passing star might stir a comet cloud once in a great while, But worlds in stable orbits around their suns rarely suffer sudden evictions. Life, if it arises, can count on eons of stability in the local sky. That quiet is an emergent property of low density and vast scale. It is serenity written into the typical street plan of the disk, with houses far apart and traffic guided by slow, predictable rules. The halo adds a contrast that reinforces the theme. Stars on wide, eccentric paths spend most of their time far from the center, where the potential changes slowly. Streams of tidal debris wrap around in graceful arcs. Their density fades as they lengthen, and the folds overlay until the background appears smooth. The halo is a museum of past motion, not a marketplace of present jostling. Even its irregularities are tapestries rather than riots. Mathematically, the long view leads to distribution functions that depend on integrals of motion and perhaps on a handful of adiabatic invariants that persist under slow change. Observers infer these functions by fitting them to star counts and velocities across large regions. The fits succeed, which feels like philosophy disguised as algebra. A simple dependence on conserved quantities captures the behavior of hundreds of billions of orbits. The success is not an accident. It reflects the fact that most paths repeat themselves with minor variations. Repetition is not boredom, it is reliability. Small-scale structure can exist in the interstellar medium and in clusters, but the disk as a whole avoids fragmentation into disaster because shear peels grow in clumps apart unless self-gravity and cooling are strong enough to resist. The balance denies both perfect smoothness and total collapse. Instead, it breeds a hierarchical texture with a finite upper scale. Clouds form stars, disperse, and reform elsewhere. The background potential barely notices. The large stage remains level even while scenes change upon it. On the largest scales, the unseen component steadies the act. A massive, diffuse halo provides a gentle well that keeps rotation from declining too sharply with radius. That graceful curve in speed reduces the differential shear that might otherwise shred structures quickly. It also reduces the need for stars to rely on the self-gravity of the disk alone to prevent escape. The invisible mass acts as a cushion, letting the luminous matter glide within a wider embrace. The effect is not exotic in its spirit. It is architectural, like a foundation under a floor that flexes but does not crack. He contemplates the sum of these facts and senses why the mind rests when it pictures the galaxy. Collisions are almost absent, encounters are rare and slow, mixing is both inexorable and delicate. Resonances give music to the traffic. Stability criteria keep the system poised. Chaos appears, then meanders rather than pounces. An ocean of orbits follows shared rules that resist rash outcomes. The quiet is not emptiness. It is the quiet of a city that has learned rhythm, a city that hums because every inhabitant moves with respect for the common field. He follows a soft glow rising above the plain and learns to read time in height. A second layer rests over the bright midline, thicker, older, quieter in its way. Its stars drift with firmer steps and carry a chemistry that speaks of quick forging long ago. This is the thick disk, a memory made visible, a vertical archive of how a galaxy learned composure. A census reveals its traits with patient clarity. The scale height stretches close to 1,000 parsecs, several times the thin layer beneath. Random motions run higher in every direction, with radial and vertical dispersions that make paths puff outward from the midline. Metallicities lean modestly below solar on average, yet the ratio of alpha elements to iron rises. That ratio is a clock. Alpha elements come fast from massive stars that die as core collapse supernovae within tens of millions of years. Iron from type Ia follows on a slower fuse. A high alpha mark implies an era of rapid, intense star formation that did not pause long enough for the later iron tide to dilute it. The thick disk holds that mark like an old scar made smooth by time. Ages cluster toward 10 billion years and older. The chronology places these stars in an epoch when gas was abundant and turbulence was a constant companion. Back then, the disk was hotter in kinematic terms, with clouds colliding and clumps assembling and dissolving on short intervals. Stars born in such a setting inherit the agitation of their cradle. They lift above the plane, and keep that posture as if refusing to sit. The calmer layer below arrives later, a sign that the storm settled and that the birthplace is cooled. Different formation stories fit these signatures and are not rivals so much as layers of one tale. One story proposes that many were born thick, a gas disk stirred by strong accretion, gravitational instabilities, and vigorous feedback turns out stars with high dispersions from the start. Another story offers heating by events that follow. A merger with a smaller galaxy shivers the pre-existing disk, inflating orbits and mixing chemistry. Both speak to the same truth. The early epoch granted energy to orbits. Afterward, the input waned and the system matured. Clues in chemistry sketch a clean diagram. Plot alpha enhancement against iron abundance and two sequences appear. One is thick, high alpha, stretching from metal poor to near solar metallicity. The other is thin, lower alpha, winding its own path. The thick sequence is narrow, as if a single dominant enrichment history shaped it. Rapid birth, quick recycling, little time for iron to accumulate. The thin sequence is broader, reflecting slower, more prolonged star formation and more mixing from delayed supernovae. The grace of the diagram lies in how quietly it separates epochs without needing a calendar. Kinematics add depth. The older, alpha-rich population spins around the center with a mild lag compared with the younger layer. The difference is not a sign of rebellion. It is a witness to angular momentum exchange during that formative era, and to the mild braking that comes with added random motion. Orbits tilt more above the plane as vertical oscillations grow. The result is a thickened lantern that keeps its overall rotation yet wears its age on its posture. Radial migration paints subtle gradients across this layer. Stars do not stay at one guiding radius forever. Resonances with patterns in the disk can shift angular momentum without heating epicycles. In the thick component, such churning is less potent than in the cooler layer below, but it is not absent. Migrants bring their chemistry with them and soften spatial contrasts. An observer notices that the alpha-rich sequence persists from inner to outer regions, its prominence adjusting but not disappearing. The thick disk thus knits the galaxy by slowly trading citizens across neighborhoods. Vertical metallicity trends speak a calm language, move away from the plane and the iron abundance falls gently, while alpha enhancement rises. The gradient is smooth, not jagged, a sign that mixing has been thorough on large scales. The absence of sharp steps implies that whatever heated or built this layer did so broadly and early. Later episodes have lacked the force to carve new, distinct strata. Serenity here is the product of completion. The heavy work finished long ago, leaving a refined patina rather than fresh marks. Structural shapes vary with radius. In the inner few kiloparsecs, the thick component blends into a boxy swelling supported by bar orbits. Farther out, it flares mildly, with the scale height growing as the disk thins in density. The flaring does not announce itself with cliffs. It rises like the edge of a distant sea under a warm wind. This subtle widening eases the transition toward the halo, letting vertical excursions lengthen without abrupt change in family traits. Star clusters contribute a careful note. Open clusters are mostly children of the thin layer, fragile and short-lived as bound groups. A minority are older and higher, and those survivors tell of formation in an era when disruption was common, yet some pockets sheltered long enough to leave descendants. Their orbits and chemistry tie them to the alpha-rich sequence, and thus to the same formative rhythm. The existence of any such clusters hints that the thick disk was not pure frenzy. Even turbulence pauses, and in those pauses, memory found anchors. Gas dynamics during the formative epoch holds a key. Accretion from the circumgalactic medium and from gas-rich companions fed the disk at high rates. That inflow maintained a pressure-supported layer where clouds were heavy and feedback carved bubbles that closed quickly. Outflows lifted metals and later rained them back, a fountain that redistributed enrichment vertically and radially. Stars formed rapidly in this thickened atmosphere. Then the supply eased, the pressure fell, and the midplane cooled enough to gather the thin layer that now dominates the light. The two strata are stages of one breath. Events of external origin left a quiet watermark. A notable merger on a retrograde or inclined path can inject heat efficiently into orbits, and thicken the disk while sprinkling distinct chemical fingerprints into the mix. Streams in the halo preserve the most dramatic remnants, but the disk records the energy transfer more discreetly. Dispersions rise. The vertical density profile stretches. The alpha-rich sequence, born in a bursty climate, absorbs the jolt and then continues aging with little further disturbance. The violence diffuses into equilibrium, a transformation that defines the layer's gentle authority. Dynamics in the present keep the thick disk steady without freezing it. Encounters with spiral waves and the bar at resonant radii still nudge actions. The rate is slow. Over billions of years, the population drifts in velocity space like smoke, expanding in a room, never pooling to a draft. The vertical oscillation frequencies ensure that stars cross the midplane regularly, sharing their gravity with the thin layer and subtly coupling both strata. The partnership stabilizes the whole. The thicker population acts like a ballast that resists excessive bending and warping, while the thin layer provides most of the fresh light and gas processing. The observational signature of this calm ballast appears in how star counts fall with height. A two-component model, each with its own scale height and normalization, fits the data with ease across vast areas. The simple form is not naive. It is prophetic. It says that separate epochs built distinct but harmonious structures. Their superposition, far from messy, yields a profile that mathematicians like for its economy and that observers trust for its fidelity. He contemplates what this vertical memory grants to a world inside it. A star like the Sun lives near the midplane, but not alone there. Above and below, elders glide with a touch of sternness, their paths a little braver, their chemistry a little older. Their presence cushions the plane. It also offers a record in nearby atmospheres and rocks. Elements forged in the thick disk era seeded later generations with a composition that favored long-lived stars and stable planetary crusts. Calm, in this sense, is inheritance. The thick disk embodies a lesson in how to age. Born in speed, it settled. Shaped by heat, it became a stabilizer. Marked by a swift forge, it now moderates the chemical climate of the present. It rises above the bright line not to dominate, but to reassure. When he imagines looking upward at that older layer, he understands that serenity can be a memory kept in motion, a choice made early and maintained by the refusal to overreact. A galaxy learns this posture once. After that, it keeps it with grace. He lifts his gaze above the bright disk and finds a country of almost nothing. A faint population drifts through a vast sphere, so dilute that a handful of stars can own a cubic parsec. This is the halo, a breath around the galaxy, so light that it seems like a thought held between sentences. It has no plane, it has no obvious wall. It is a slow shell of motion, a gathering of orbits whose periods can exceed 1 billion years. Calm arrives here because time stretches so widely that even change seems to rest. Starlight in this realm is sparse and old. Blue horizontal branch markers and ancient variables serve as beacons, and their distribution fades with radius in a gentle law. Close in, the density drops steeply. Farther out, the decline relaxes into an even softer fall. There is no cliff. There is only a thinning that speaks of a long memory of accretion and of tides that have pulled and rewrapped populations around the central mass. The metallicity leans low, a sign that many of these stars were born in small systems with modest chemical histories. The halo is a collage of arrivals rather than a single tribe grown in place. Streams draw the map in lines too subtle for the naked eye, but crisp under patient surveys. Each stream is the stretched remnant of a cluster or a dwarf galaxy that wandered too close and found its stars teased free. The freed stars do not scatter. They file along the original orbit, wrapped ahead and behind, forming cold ribbons that paint the gravitational field. These ribbons curve across the sky in graceful arcs. Some show folds. Some display gentle gaps where encounters with lumps of invisible mass have perturbed their flow. None are violent. They are calligraphy written in centuries the way a glacier writes valleys. Globular clusters roam through this region like compact clocks. Their deep binding lets them survive passages that shred looser systems. Tails of stars leak from some, forming symmetric plumes that point along their paths. The clusters themselves are old, and their motions trace a geometry that is rounder than the disk and slightly flattened by the past pull of the central mass. Their metallicities sort them into families, some with higher iron content and orbits confined closer in, others with lower iron and paths that soar outward. The families whisper of origins in both in situ bursts and in swallowed companions. The overall whisper is reassuring. Many pathways can lead to coherence. The shape of the halo is not perfectly spherical. It can be slightly oblate within tens of kiloparsecs, then drift toward a rounder form farther out. The reason is practical. The disk and the bar flatten the potential near the center, encouraging orbits to align in a subtle waste. With increasing radius, the influence of the disk fades, and the dark matter domain dominates, lifting the figure towards symmetry. The shift is quiet. The transit from one shape to the other is a long glide, not a switch. A break appears in the radial profile of star, counts at a few tens of kiloparsecs. Inside that distance, the density decreases steeply with radius. Beyond it, the fall becomes more gentle. The break is not a boundary. It is a memorial to how the galaxy grew. Material assembled early tends to orbit closer. Later infalls from satellites sprinkle stars farther out. The mix creates a shoulder in the profile. The eye can read it as an exhale, a place where the breathing of assembly changed from deep to shallow. Kinematics here carry a signature of freedom. Velocities point more often along radial directions than along tangential ones. The anisotropy reveals that many halo stars ride paths that plunge inward and then linger far away before returning. Such orbits spend most of their time near apocenter, where motion slows and views widen. If one could follow a single star for a full circuit, the patience required would outlast empires. Serenity comes with such periods because nothing can rush a trajectory that wide. Satellite galaxies slice through this space like small lanterns. Some still retain gas and show star formation, especially those on wider paths. Others have been stripped to their stellar bones, quenched by tides and by the pressure of the hot coronal gas that fills the galaxy's extended atmosphere. Their orbits and distortions hint at the geography of the whole. A group that entered as a caravan can share a coherent motion and shed debris into parallel streams. One massive traveler in particular can raise a wake in the halo, pulling stars and dark matter into a trailing overdensity that slightly shifts the center of mass. These are not storms. They are the long swells that follow the passage of a ship across a calm sea. The hot corona sets the thermal tone for the larger halo. At temperatures of a few million degrees, thin gas pervades hundreds of kiloparsecs, luminous in X-rays yet almost invisible to human senses. It holds metals recycled from the disk and from earlier generations of outflows. It slows inbound gas, feeds a slow fountain that returns material to the disk, and strips satellites that venture deep into it. The pressure it provides cushions the dark halo, helping to keep the outer rotation curve smooth and the inflow of fuel regulated. Heat, in this case, supports quiet. Where does the halo end? The answer depends on the language chosen. The stellar halo fades into a level too low to measure, at a few hundred kiloparsecs, but faint streams and satellite paths extend beyond that, part of a shared environment that touches the rest of the local group. The dark halo is often defined by a radius where the average enclosed density falls to a fixed multiple of the cosmic mean. That radius lands around a couple of hundred kiloparsecs for a galaxy of this mass. Beyond it, the gravitational influence does not vanish. It simply yields to the general tug of neighboring structures. A different definition draws the line at the farthest apocenters of bound traces. That boundary drifts as data deepen. Every definition respects the same truth. The edge is a slope, not a fence. Escape speed softens with distance. Near the center, it is high enough to hold fast winds for a time. Farther out, the threshold falls, and particles can leave if their energies exceed the local well. The fall in escape speed is smooth. No one crossing feels a step. Streams inch past their apocenters and turn back in slow arcs. Unbound or nearly unbound members glide on to become part of the intergalactic population. The galaxy breathes out gently, while drawing in through cooler filaments that sink along dark scaffolds. Exchange proceeds without drama. Perturbations by unseen subhalos leave faint fingerprints along streams as underdensities and deflections. These imprints tell of a population of dark clumps that never lit up. The evidence arrives as absences along a ribbon rather than as fireworks. The method of reading such signs suits the mood. It is astronomy by listening to quiet gaps. Even in the outermost regions, the diagnostics of mass favor patience over spectacle. The geometry of the halo tilts the disk slightly in its outer parts. A long-period warp lifts one side of the outer gas layer above the midplane and depresses the opposite side. The amplitude grows with radius, where self-gravity weakens, and external torques matter more. The warp precesses slowly and likely responds to the combined pull of satellites and the shape of the dark halo. The effect is soft to the eye. It feels like a nod imposed by a companion's slow dance rather than a bow forced by a blow. The halo also plays host to ultra-faint companions, galaxies so meager that their total light resembles that of a single bright cluster. They are dominated by dark matter, with stars that formed in brief spurts long ago. Their survival in the outskirts speaks to the gentleness of tidal forces far from the center. Closer in, similar systems show tidal tails and high internal dispersions. The gradient from survival to dissolution is long. The galaxy offers distance as a refuge and proximity as a test. Many choose the refuge and orbit for ages. Time in the halo is a painter with a soft brush. Discrete events smear into continuous profiles. Orbital phases stretch into gradients. Chemical abundance distributions overlap into smooth curves. The sum is not blandness, it is harmony. Each contribution retains enough character to be found by those who look closely, yet the whole remains composed. The boundary between belonging and the general dark of intergalactic space is a place where one can feel both the galaxy and the cosmos at once, neither shouting over the other. He imagines riding with a star that has just reached apocenter at 200 kiloparsecs. The sky would show the disk as a pale coin, the streams as ghost paths, the satellites as scattered embers. The rest would be a depth of black that is not empty, only quiet. The pull toward home would be slight but sure. The return would take an era, no hurry would change it. In that picture, he understands why the halo relaxes him. It is a reminder that some journeys ask only for steady hearts and long patience. He moves inward toward a darkness that glows with restraint. At the center waits a mass about 4 million times the sun, compact enough that light itself learns new manners near its rim. Yet the scene is not a tempest. The core is a quiet hearth most nights, with brief embers that flare in infrared and X-rays, then fade. The presence steadies the innermost city of stars without the clamor of a quasar. Gravity holds court with a patient temper. Stellar orbits draw the proof with elegant lines. A handful of bright tracers, sometimes labeled with single letters and numbers, sketch ellipses around the dark focus. One of them completes a full circuit in roughly 16 years, swinging into a pericenter only a few score astronomical units from the unseen mass, and then coasting out again on a path longer than a lifetime. At closest approach, its speed climbs to a few percent of light, and its light shifts in ways that match general relativity's predictions. Gravitational redshift bends its spectrum. After each circuit, the ellipse rotates by a small angle, the famous advance of periaps that Einstein's equations demand. The drawing on the sky is a lesson in calm power. No hustle is needed when mass concentrates so perfectly. The central region is crowded by the standards of space, yet even here the distances keep encounters dignified. A nuclear star cluster fills the inner few parsecs, with old red giants, faint dwarfs, and a younger cohort that puzzles the imagination. Fresh blue stars circle within a few tenths of a parsec, some in a warped disk, some on more scattered tracks. They are too young, given their massive nature, to have wandered far from nurseries. Their birthplace must have been nearby, perhaps in a dense gaseous disk that formed under the black hole's gaze and quickly turned pockets of gas into stars. Another possibility is that binaries, nudged by tidal fields, were split, leaving one star bound on a tight orbit while the other fled. Either way, youth flourishes where tidal forces could easily erase fragile beginnings. The paradox resolves into method when the environment is understood. Gas arrives from multiple directions at many speeds. Winds from massive stars in the central parsec blow streams of plasma that mingle and collide. Some fraction of that material finds its way inward. Much of it misses the tiny target and remains in a hot, diffuse flow. The rate at which matter actually reaches the last few gravitational radii is low compared with what a hungry engine would consume. Radiative efficiency is reduced by the heat and the geometry of the inner flow, a regime often called radiatively inefficient accretion. Energy dissipated by friction stays in ions that do not radiate easily, and then leaves with outflows rather than as light. The result is a dim nucleus relative to its mass, a lantern with most of its fuel stored rather than burned. Occasional flares brighten the view. Magnetic reconnection in the inner flow, or a sudden gulp of denser gas, can light the region for an hour or a day. Hot spots seem to orbit close to the last stable circles allowed by the space-time geometry, their emission modulated by relativistic beaming and lensing. Astronomers watch these events like campfire sparks and read in their timing and spectra the scale of the engine. Between flares, the center returns to a soft glow, proof that a black hole can dominate gravity while barely disturbing the peace. A ring of molecular gas circles a few parsecs from the hole, a circumnuclear disk with clumps and filaments. Ultraviolet light and shocks illuminate its edges. Inside that ring, the interstellar medium turns atomic and then ionized, forming arcs and streamers that wind toward the center. None of these structures look frantic. They resemble a slow river delta, with channels that braid and rejoin. The black hole dictates the direction of the slope, but not the turbulence of every eddy. Farther out, the bar and the overall potential guide the delivery of fresh material, feeding the inner zones with a cadence that avoids either famine or flood. The sphere of influence of the central mass spans a few parsecs, defined by the radius where its gravity outweighs the pull of the surrounding cluster. Inside that distance, orbits feel the black hole most strongly, and the velocity dispersion rises. Outside, the collective mass of stars and dark matter takes over and sets the kinematic tone. The transition is graceful, not abrupt. A star drifting inward along a long ellipse senses the change as a slow tilt in the balance, the way a walker feels more of a mountain's pull when a valley is left behind. Tidal forces in this domain are real yet selective. A giant cloud that grazes too close can be stretched and stripped, but dense clumps can survive and even trigger star formation if compressed by shocks at the right moment. A star that dives too near would be torn. Most do not dive that deep. The distribution of orbits includes some with high eccentricities, yet pericenter distances still exceed the threshold for disruption for the common residents. The system writes its own etiquette: approach, circle, retreat. The line of respect is clear and typically obeyed. The central spacetime may rotate. If so, it drags nearby inertial frames and slightly twists the orbital planes of the closest stars, a phenomenon known as frame dragging. The effect is subtle, tiny compared with the more dominant Schwarzschild precession, and it demands long patient watching to separate from other sources of torque. The possibility is a quiet thrill. Spin would encode the history of accretion and mergers. A near zero value would hint at a balanced diet of counter-rotating inflows. A large value would hint at a long-remembered preference. Jets are weak or absent. In some galaxies, the central engine launches narrow beams that spear through the halo and light up intergalactic space. Here, the engine hums at a low setting and sends only mild outflows, perhaps a puffy wind rather than a spear. Radio images show a compact source with hints of structure on scales larger than the event horizon but far smaller than the circumnuclear ring. The absence of dramatic jets reinforces the theme of moderation. Energy leaves, but it leaves as a breeze, not as a gale. The shadow of the hole has been imaged as a warm ring with a darker center, the silhouette of light bending around the last safe orbits. The picture does not roar. It whispers a scale, a few tens of micro-arcseconds across, and confirms that gravity funnels spacetime into a bowl, as theory insists. Variability blurs details because the inner flow evolves during the time needed to collect a crisp image. Even the blur has a lesson. Nature is not obliged to hold a pose. The core is a living hearth. Stars in the region carry scars of tidal interactions with each other and with the broader cluster. Some red giants show depleted envelopes, as if past brushes with denser gas or close passages skimmed their outer layers. Compact remnants, white dwarfs and neutron stars and black holes of lower mass, likely drift toward the center over long times through dynamical friction and populate hidden orbits. They may occasionally pair and merge, sending brief murmurs into spacetime itself. These are quiet events compared with the cataclysms of distant, active galaxies, yet they add texture to the story of a nucleus that is busy in soft tones. The calm authority of the central mass stabilizes the inner rotation of the galaxy by anchoring orbits that would otherwise wander under mutual stirring. It provides a reference point around which the nuclear star cluster defines its structure. It moderates by existing, not by acting. When gas does reach the brink and crosses the last orbit, it does so invisibly until the final stretch, adding mass in tiny increments. Over cosmic time, those increments tally to a respectable growth, yet at any moment the process is nearly silent. He imagines hovering a handful of light hours from the event horizon, far enough to remain safe, close enough to feel the geometry. The star field around would smear into arcs when seen through the bent light. Time would dilate, turning heartbeats into long contemplations. The core would not announce itself with thunder. It would express gravity as a perfectly shaped promise that nothing need hurry here. Even light takes its time to leave, curving and looping before finding a path outward. At this scale, serenity acquires a new meaning. It is not the absence of force, it is force focused into a form that rarely needs to change. A compact mass holds order by being the simplest object in the landscape. No surface to weather, no atmosphere to storm, no crust to quake. Only a horizon that marks the end of where words like inside and outside make sense. The details of flow and flare play around that core like sparks around an anvil. The anvil does not answer in sparks. It answers in steadfastness. He steps back in mind and pictures how this steadfastness ripples out. The orbits of the inner parsec trace their lanes in abeyance. The inflowing gas takes the shape allowed by pressure and angular momentum and then relaxes or departs. The nuclear cluster balances youth and age in a way that keeps the region luminous but not unruly. The black center remains content to be the center, and by being so, it grants calm to everything within reach. He senses an architecture he cannot see, a framework that never shines and yet shapes everything that does. Around the luminous disk lies a vast reservoir of mass that neither glows nor glitters, a smooth halo that steadies rotation and gathers the streams of the outskirts. It is an invisible scaffold that turns the galaxy into a long-term promise. The calm that follows from this unseen weight is practical. With extra mass distributed over great distances, orbits do not suffer abrupt surprises. The curve of rotation that might have fallen with radius instead remains nearly flat for a wide span, a sign that the outskirts are held by a hand that does not tire. Measurements of speed around the galaxy reveal the signature. Gas clouds orbit at similar velocities from the inner tens of kiloparsecs to regions far beyond the bright star fields. If only the visible disk and bulge were present, those speeds would decrease with radius as gravity weakened. The data whisper otherwise. They imply a spherical or slightly oblate envelope of mass that grows with distance. This envelope contributes most of the gravitational pull in the outer parts. Light fails to trace it, yet motion obeys it. The agreement across different tracers feels like a lullaby played by multiple instruments on the same key. Near the sun, local tests add quiet details. The vertical motions of stars above and below the plane respond to the combined pull of disk and halo. By charting how that motion changes with height, astronomers infer a local mass density slightly larger than what luminous matter can supply. The difference is modest but steady. It matches a picture in which an invisible component threads the neighborhood without clumping into bright objects. Microlensing surveys strengthen the impression by constraining how much of the missing mass could be compact lenses, such as faint stars or dead remnants. The bulk cannot hide as little bodies. It prefers to be diffuse. Models of the halo's radial profile often take simple mathematical forms that grow close to the center and ease into a shallower decline in the outskirts. Some curves rise sharply toward the core, others soften into a flat region before falling. Subtle distinctions matter to specialists, but the broader message is soothing. In any of these profiles, the extended mass spreads the gravitational field and removes cliffs from the potential. Stars in the disk feel a gentle background that changes slowly with radius and height. Stability loves such gradients. Simulations that grow galaxies within a cosmic web routinely produce halos of invisible matter well before gas cools and settles into disks. These halos collide and merge, then relax into nearly universal shapes. Baryons arrive later, bringing radiation, chemistry, and stars. Feedback from those stars can reshape the inner potential by pushing gas around, sometimes transferring energy to the dark distribution and carving a shallower central profile. Whether the center is cusped or cored remains a conversation in progress, but the conversation itself underscores a steady truth. On scales that matter to the whole disk, the invisible mass forms a capacious bowl that keeps the luminous layer comfortably seated. The quiet scaffold moderates bar and spiral evolution by granting the disk an anchor much larger than itself. Known axisymmetric features exchange angular momentum with the halo. Over long spans, this exchange lets bars grow and slow gently rather than crash or vanish. The halo absorbs some of the turbulence that would otherwise stay trapped in the disk, turning violent rearrangements into slow adjustments. It acts as a reservoir that can take a nudge without ringing loudly. The outcome is persistence without rigidity, a style of support that favors grace. Substructure lives within the darkness as knots and clumps that never lit up. Their gravity is real even if their faces are not. When such a clump grazes a stellar stream, it perturbs the ribbon and leaves a faint gap or a bend. When it passes through the outer gas layer, it may stir a ripple that fades as it spreads. These traces whisper of a population beneath detection by light. The key point is that even with substructure, the overall halo remains calm. Most clumps are small compared with the whole, and their effects are modest and rare. The scaffold holds while allowing small eddies to pass. The halo sets the escape speed at every radius. Near the Sun, that threshold is high enough that typical stars remain bound for eons, even if their random speeds are elevated. Only rare travelers launched by extreme interactions come close to freedom. Their trajectories outline the well of the potential, like pebbles thrown toward the lip of a deep spring. Farther out, the escape speed falls smoothly, and tracers at the edge of the system mark the transition to a domain where the galaxy yields to the general tug of the local group. The slope of this descent documents a mass enclosed that grows with radius to a few hundred kiloparsecs, a total that places the Milky Way among the sturdier spirals. Sturdy is a relaxing word in this context. It hints at longevity. Alternate ideas about gravity have been offered to explain flat rotation without unseen mass. Some propose that the law itself changes at very low accelerations, bending Newton's familiar rule into a new curve on galactic scales. Such proposals work well for certain rotation curves and struggle with others, especially where independent evidence signals extra mass during mergers and strong lensing in more distant systems. The debate is an honest one, but within this particular galaxy, the ensemble of clues favors a halo of invisible matter that couples to gravity in the usual way while interacting scarcely at all with light. Accepting that picture allows the rest of the story to settle into coherence. Candidates for the invisible substance arrive from particle theory. Some are heavy and slow, interacting only through gravity and possibly the weak force. Others are light and wave-like, filling halos with a quantum pressure that can smooth the smallest scales. A third family interacts with itself, exchanging momentum in ways that could soften dense cores while still behaving as a pressureless fluid on larger scales. None of these candidates has yet been caught in a laboratory. The fact that the galaxy's kinematics point to their presence remains one of the most calming provocations in modern thought. There is a mystery carrying the weight of order, and it carries that weight quietly. The thermal history of the unseen also matters. If formed cold and heavy, the particles clump efficiently and produce many small subhalos. If born warmer, they erase the tiniest structures and yield a smoother distribution. The Milky Way's streams and satellite sensors speak to this balance. The number and properties of small companions, the pattern of gaps in ribbons of stars, and the thickness of cold tidal traces all lean toward a universe that permits many little knots but not an infinite swarm. The result again is measured balance, enough substructure to reveal the scaffolding, not enough to turn the outskirts into a maze. Closer to the plane, the halo contributes a portion of the vertical restoring force that pulls stars back toward the midline. The disk provides a sharper tug near zero height. The halo adds a steady hand over larger distances. Together, they create epicycles and vertical bounces with frequencies that change gently with radius. That gentle variation prevents resonant catastrophes across broad bands and confines strong resonances to well-defined places where they can be studied and even used as tools. The potential respects boundaries without building walls. Gravitational lensing offers a check that does not ask stars how they move. When light from distant sources passes near massive objects, it bends. In principle, maps of the sky could reveal small distortions in many background images that sum to a picture of the intervening mass distribution. For distant clusters, this method is routine. For the Milky Way, the geometry is trickier, yet microlensing toward the bulge and hints of weak lensing at wider angles agree with a dark envelope that outmasses the luminous one. Even when lensing is subtle, it sings the same note as kinematics. The chord feels consonant. The hot circumgalactic medium floating at millions of degrees partakes in this architecture. Though not itself the main unseen component, its distribution and pressure are set by the joint pull of dark halo and stellar mass. It settles into a quasi-hydrostatic balance that mirrors the shape of the potential and provides drag for satellites while feeding a gentle rain back onto the disk. The coupling among hot gas, invisible halo, and stellar structure closes a loop. The galaxy retains fuel without hoarding it. It cools without collapsing. It exhales without emptying. He contemplates the most restful feature of the whole picture. The invisible mass is patient. It responds only to gravity and perhaps to a faint whisper of other forces. It does not radiate away energy like gas. It does not shatter like a solid. It does not conduct heat like a metal. It is a tranquil participant that holds configuration for billions of years. Because it lacks the channels that drive rapid change, it becomes the guarantor of slow change. On that guarantee, a disk can write spirals that last, and a bar that evolves without panic. Planets can orbit stars that orbit the center, while the scaffold merely watches. There is a quiet humility in admitting that most of the mass is unseen. Humility can be calming. It asks a mind to allow for a presence that declines to be photographed but is obvious in every curve of speed and every shape of stream. The conclusion feels like standing in a cathedral at dusk and sensing the weight of the stone vault without seeing each block. Sound carries differently. The temperature is cool. The air smells of age. The vault does not announce itself with trumpets. It announces itself by the way it makes everything else possible. He listens for rhythm in the city of stars and hears certain notes repeating with patient insistence. Resonance is the quiet secret. When an orbital frequency meets a pattern frequency in a simple ratio, small tugs add rather than cancel. The result is not an uproar. It is a steady shaping of paths into rings, gaps, and streams that keep time with the galaxy's slow music. A disk becomes a metronome made of mass. 3 frequencies carry most of the melody. One is the circular rate around the center, another is the epicyclic rate that measures the tiny in and out oscillations around a guiding circle in the plane. The third is the vertical bounce above and below the midline. Patterns such as a bar or a spiral rotate with their own angular speeds. Where combinations of these rates align, orbits feel the same nudge at the same phase, turn after turn. Over millions of years, those whispers accumulate into architecture. Corrotation is the calmest of these alignments. There, matter and pattern share the same average angular speed. A star drifts beside the crest of a spiral or the elongated field of a bar as if walking with a companion. Exchanges of angular momentum happen gently. A star can trade a little, and shift its guiding radius without heating its epicycle. This is radial migration by churning. It moves citizens without making them restless. Chemical gradients soften, yet the thin layer stays cool. Order spreads not by stirring but by reassigning addresses. The inner and outer Lindblad resonances are sharper notes. At the inner one, the difference between circular rate and pattern speed equals half the epicyclic rate. At the outer one, the sum equals half the epicyclic rate. In these neighborhoods, the periodic pulls add kinetic energy to radial motion. This is blurring. Stars grow slightly warmer in the plane. Gas responds in a more graphic way. Shocks and crowding guide it into rings that can be traced by dust lanes and star formation. Near the inner resonance, a tight ring can encircle the central zone like a glowing bracelet. Near corrotation, a broader ring may form. Near the outer resonance, arcs of light often loop around the ends of a bar and knit into complete circles or figure eights, known for their elegance. These features look like ornaments. They are clocks. Vertical resonances add a quieter harmony that shapes thickness. Where a combination of in-plane motion and pattern speed couples to the vertical bounce, orbits are lifted into larger excursions above and below the disk. Over long spans, this elevation sculpts a central swelling with a boxy or peanut flavor when viewed from the side. The geometry appears architectural, as if beams had been placed to brace the vault. Yet, no one planted beams. Orbit simply chose new loops that satisfied balance in the rotating frame. Resonance leaves fingerprints in the motions of local stars. Velocity space near the Sun shows ridges and branches rather than a single blurred cloud. Each ridge corresponds to families of orbits that share similar actions and have been nudged by the same resonant structures. Some groups lag or lead the average rotation, others carry extra radial motion. The pattern is not youth preserved from a common nursery. It is choreography imposed by frequencies. The eye that once saw randomness now reads script. Subtle spirals appear in the plot of vertical motion against height, a curling pattern of phases that winds like the growth rings of a shell. The curl is a sign that something tipped the vertical balance a few 100 million years ago and set the bounce angles out of sync. Since then, differential frequencies have wound the scatter into a spiral. The cause can be a passing satellite or a ripple from a shifting bar or arms. Whatever the trigger, the aftermath is serene. The pattern relaxes as it winds, and the disk absorbs the memory as a gentle corrugation. Gas responds to resonances with the clarity of ink in water. At shocks aligned with bar-leading edges, molecules compress and cool. Rings at favored radii collect fuel, and there star formation proceeds at rates regulated by orbital timescales and pressure. The result is a chain of clusters that ages along a ring's flow, lighting arcs like a string of lanterns. Because the positions are set by kinematics, the city plan persists while individual homes change. Ordre survive turnover. Resonance overlap, where the domains of different patterns brush or interlace, could in principle breed chaos. In practice, in a disk like this, the overlaps are modest. The bar keeps its corrotation just beyond its tips. Spirals of various multiplicities drift with pattern speeds that avoid permanent locks except in limited sectors. The diffusion that occurs where influences meet is slow. It broadens ridges rather than erasing them. The long-term effect is seasoning, not fire. Mode coupling transfers power between patterns without drama. A two-armed spiral can excite four-armed responses. A bar can seed outer waves through its outer resonances. These children do not rebel, they echo. Their phases drift, they surge and fade, and together they maintain the grand design at a gently variable contrast. To an observer who watches for a decade, nothing seems to change. To one who could watch for 500 million years, the arms would breathe like tides. Measuring pattern speeds is its own art of stillness. Luminosity-weighted methods track how features drift across slits and derive a single number that best fits a rigid rotation of the pattern. Star-forming tracers with known ages line the arms, and their offsets from dust lanes give a clock. Maser spots in dense clouds, with precise distances and motions, mark streaming near corrotation. Each method is a watch with a different face. When the times they tell agree, confidence grows that the metronome is well read. Resonances can capture and later release orbits as conditions drift. If a bar slows gently by handing angular momentum to the halo, its corrotation moves outward. Stars near the moving boundary can be swept along, carried to larger guiding radii while preserving coolness. Likewise, as gas accumulates and changes the inner potential, inner resonances can shift and reshape rings. The slowness of these changes keeps the process tender. Capture does not bruise. Release does not drop. The same language explains long-period bending waves. A slight tilt applied to the outer disk by the potential of a companion can align with vertical frequencies over great spans. The result is a warp that precesses so slowly that generations mistake it for a fixed geometry. Corrugations closer in ride on similar couplings and fade as phase mixing spreads their angles. What could be more restful than a wave that drifts for eons and never breaks? Resonant structure also moderates the flow of angular momentum across the disk. At inner alignments, material tends to surrender a little and move inward. At outer ones, it tends to receive and move outward. This tide is not uniform, and it does not run quickly. It acts like a set of conveyor belts that shuttle small parcels over long times. The belts allow the disk to evolve without pain. Density profiles adjust, bars lengthen, spirals renew, and the whole keeps its outline recognizable. Even the dark scaffold participates. Subtle figure asymmetries in the halo can set up weak tumbling patterns that couple to the disk at specific radii. The coupling is faint and rare, yet over time it can select certain angles and foster or suppress waves. The invisible mass becomes part of the orchestra, not a soloist, adding a low drone that supports the overtone series played by stars and gas. A star living through these corridors of commensurability would not feel a siren. It would feel a periodic tug that asks for a small adjustment at the same point in each loop. When the frequencies fit, the answer accumulates. When they do not, the answer cancels. That is the essence of resonance. It is how a child on a swing reaches higher with gentle, well-timed kicks. It is also how a galaxy keeps its house in order, with nudges too delicate to notice on a human day. He regards this and finds that the most relaxing fact of all is that balance can be engineered by arithmetic. Ratios of rates, sums and differences of frequencies, simple integers that govern complex crowds. Where those integers rule, the system builds shapes that look inevitable. Rings where gas rests, streams where stars agree, ridges in motion space that read like staff lines for a cosmic score. Nothing about this requires a shout. The mathematics hums, the orbits listen, and the city holds its tune. He traces the quiet signatures of arrival. A large galaxy rarely grows alone. Companions approach on long ellipses, surrender their stars to tides, and leave their names as structures in motion and chemistry. The surprises are not explosions but redistributions. What seems like a tranquil city of orbits is in part an archive of visits. The calm endures because energy from encounters diffuses over great volumes and long times, turning sudden meetings into gentle adjustments of shape. One ancient guest came head-on, rich in stars and poor in metals, its orbit plunging through the young disk. The impact did not shatter the system, it heated it. Stellar paths puffed upward and outward, and a population with high alpha abundances settled into thicker kinematics. The fingerprints remain in velocity space as elongated lobes, and in chemistry as a coherent track distinct from the native curve. Globular clusters share the accent, their ages and metallicities aligning with the same episode. The memory is vivid to instruments and mild to the eye. Other arrivals moved on steeper inclinations, their energies too high to be absorbed in a single pass. They looped repeatedly, surrendering momentum at each pericenter through dynamical friction, sinking slowly toward the center while shedding stars into arcs. Those arcs lengthened until phase mixing blurred them into a background that still knows where it came from. A few clusters carry family names that betray adoption rather than birth, their orbits and elemental ratios pointing outward to forgotten parents. Adoption fits the mood. The household expanded without losing poise. One small companion has drifted along a decaying path for billions of years, its body stretched into a ribbon that loops across the sky. Portions of this ribbon continue to fall, creating ripples in the outer disk and adding fresh traces to the halo. The influence is not destructive, It is like a long vessel carving a wake in placid water. Farther out, a brighter pair sails together, their mutual tides throwing a stream of neutral hydrogen across a vast arc. Their mass sets up a moving tug on the larger halo, displacing the center of pull by a subtle amount and exciting bending waves that precess over giga-years. The precession is so slow that generations of observers mistake it for a fixed warp. A spacecraft crossing the outskirts would find the gas layer lifted on one side and lowered on the other, the curvature dignified and deliberate. Encounters inject phase spirals and corrugations into the disk. A vertical nudge sets bounce angles out of alignment, and the curl in the space of height and vertical velocity begins to wind. Differential frequencies do the rest, turning an initial kink into a spiral that tightens as time passes. The pattern fades as random motions smear the phases, but before it fades, it serves as a clock that dates the last encounter. A gentle clock, counting with cycles rather than ticks. Mergers also fuel a fountain of gas. Tidal tails and ram pressure strip hydrogen from satellites, feeding the circumgalactic medium. The halo, hot and buoyant, receives the gift and returns it as a drizzle to the outer disk. When the drizzle falls, it triggers modest star formation in lacy rings and low-contrast arms, a renewal that seldom rises to a starburst. The entropy of the halo enforces moderation. It slows the rain and spreads it wide. Chemical tagging makes the narrative legible. Stars born together remember their heritage in the small ratios of elements built by different kinds of supernovae. By reading those ratios with high-resolution spectroscopy, astronomers group field stars into dissolved families. Some families point to the same infalls inferred from kinematics. The agreement feels like harmony in a choir, distinct voices blending into a chord that reveals the score. Harmony is the theme. Even where the past contains drama, the present rings smoothly. The dark scaffold mediates the meetings. As a satellite approaches, its own halo interpenetrates the larger one, exchanging energy through gravity, without friction in the ordinary sense. That exchange slows the satellite without heat or light. The stellar disk experiences the encounter as a slowly varying tug superimposed on its own field. If the angle aligns with resonant frequencies, the disk answers in bending waves and mild warps rather than in fractures. The lack of a sharp edge at the outer boundary allows stresses to travel outward and dissipate through the vast volume of the halo. The system uses size as a cushion. Even globular clusters, compact as they are, show signs of these passages. A subset lacks the multi-generational chemical patterns common in clusters formed in the main body. Their lighter element spreads, and orbital properties indicate origin in smaller hosts. Pulled free and set on new paths, they now traverse serene loops that ignore the turmoil that once delivered them. The contrast between their violent extraction and their current calm is instructive. Mobility is not the enemy of tranquility when the medium responds elastically. Not every encounter heats. Some resonant passages near corrotation exchange angular momentum without increasing random speeds. Migrants slip to new guiding radii while staying cool. Over time, this migration paints a smoother gradient in metallicity and softens traces of birthplace. Planets around such migrants ride along, carrying their atmospheres and oceans past fresh skies. The disk becomes a tapestry woven by transport as much as by local growth. At the largest scale, the local group shares a potential that blends the pull of two big parents and many small offspring. Tides from this collective geometry set the outer limits of bound orbits. The galaxy and its main neighbor fall toward one another with the patience of a deep breath, a motion too slow to raise anxiety. In a few billion years they will embrace, but the first acts of that courtship unfold as mild talks and subtle alignments. The halo notices before the disk, and even the halo responds with grace rather than alarm. Streams are laboratories for how softly gravity works when distances are vast. Cold ribbons preserve their narrow widths for long arcs because random velocities are tiny. Where gaps appear, they tell of compact perturbers that passed long ago. By measuring the spacing and shape of these gaps, one can weigh the invisible lumps that seeded them. It is a forensic science conducted with whispers. The result informs the spectrum of substructure in the dark halo without needing explosions. Whispered evidence guides a quiet verdict. The net effect of many mergers is not a jagged ruin, it is a layered city. Old stars with high alpha abundances and hot kinematics tell of early tumult. Younger populations with cooler motion and varied chemistry tell of prolonged settling. Accreted groups contribute distinct yet blended streams in action space. The planes of satellites hint at shared origin flights that arrived as associations. The whole reads like a palimpsest, earlier writing still visible beneath newer lines, both texts legible without drowning the other. He considers the timescale of forgetting. Phase mixing erases sharp edges in a few orbital periods for features near the Sun, and in more for the halo. Chaotic regions blur faster, regular regions slower. The disk therefore carries long-term memory only in fonts that suit the medium. Rings and ridges from resonant responses persist. Broad gradients in chemistry remain. Narrow clumps in position vanish. Memory chooses styles that age well. The choice calms the portrait. The delicate balance between heating and cooling, infall and outflow, stirring and settling, explains why a galaxy that has swallowed many companions still looks composed. Encounters add energy to some degrees of freedom and not to others. Dissipation in gas releases that energy without raising random stellar speeds indefinitely. The resulting system finds an equilibrium in which planes thicken to a point, halos absorb jolts, and disks continue to rotate with modest dispersions. Composure is not luck. It is the average of opposites over long time. He takes comfort in the idea that even collisions can be gentle in their consequence when space is large enough and time is generous. A small galaxy passing through a larger one sounds frightening to a mind used to crowded roads, but stars are far apart and orbits are patient. The real drama occurs in phase space, in angles and frequencies. What the eye sees is a steady band of light across the night. The band is honest. It tells the truth of many meetings, translated into a language of rings and ripples that soothe rather than alarm. He walks the galaxy by listening to its breath. Gas inhales toward cool density, dust gathers like shade under a tree, stars kindle as small embers, and feedback exhales heat and momentum back into the medium. The cadence slows restless thoughts. Nothing hurries and nothing stalls. Creation here prefers cycles to shocks. The interstellar medium divides itself into temperaments that share the same streets. Warm atomic gas drifts at thousands of degrees, thin and buoyant. Cold, neutral clouds huddle at a few tens of degrees, dense enough to feel their own pull. Ionized regions lace the spiral lanes where young stars photosionize their surroundings. Hot bubbles flare to millions of degrees where supernovae have recently stirred the pot, then cool as they expand and merge into a ragged foam. Pressure finds a balance across these phases, even when temperatures disagree by factors of a million. Thermal instability and gentle turbulence sort parcels into niches where they live quietly until nudged again. The city remains in conversation rather than in argument. Dust grains, forged in dying stars and grown in molecular clouds, become the caretakers of calm. They dim harsh light, shield molecules from radiation, and offer surfaces where simple atoms meet and clasp hands as hydrogen pairs. In the hush behind a column of dust, the temperature falls, carbon monoxide lights up, and molecules mark the entrance to the densest rooms. Observers follow that glow as if tracing lamplight through fog, and find clouds, thousands of solar masses in weight, tens of parsecs in size, and filigreed with filaments. Magnetic fields thread these rooms, adding a soft tension that resists sudden collapse and guides the flow along ordered lines. The balance of gravity, turbulence, and field turns a potential avalanche into a slow settling. The lifetimes of these giant clouds stretch to a few tens of millions of years. During that span, turbulence decays unless driven. Spiral shocks, shearing flows, and feedback from the firstborn stars replenish it. The result is a maintained roughness that prevents all the mass from rushing to the center at once. Within that roughness, filaments form and crisscross like the grain in wood. Subtle oscillations squeeze certain segments until they neck into beads. Dense cores bloom along the strands, each only a fraction of a parsec wide, each cooled by molecules and dust to temperatures where motions are slow and sound is a whisper. A tiny fraction of the cloud's mass reaches these sanctuaries. The rest remains scaffolding and buffer. Gravity wins inside a core when the weight exceeds the support provided by thermal pressure, magnetic tension, and waves. The win is measured, not aggressive. Collapse takes many freefall times because outflows and radiation from the forming protostar push back. As gas swirls in, angular momentum segregates a disk around the infant star. There, grains stick, grow, and begin the patient work of building planets. Jets lance out along the rotation axis and carry away excess spin, their slender lines carving cavities through which light escapes. The scene is active, yet muted. Most of the energy emerges in infrared through dust that glows with quiet warmth. A rare minority of cores form massive stars whose lives are brief and brilliant. Their ultraviolet light creates ionized bubbles that expand into the cloud. Their winds sweep shells that thicken and then shatter into fragments where new stars can spark. Eventually, a few finish as supernovae, sending shocks that compress remote pockets while clearing the old cloud. Even this violence becomes part of the restraint. The energy spreads over volumes larger than any one nursery and leaves behind a medium that is stirred but not shredded. Where densities are high, cooling is efficient, and the shock becomes an organizing touch more than a destroying hand. On galactic scales, the rate of birth aligns with the amount of molecular gas like tide to moon. Map the surface density of cold gas, and a law emerges that turns that density into star formation per area with a simple curve. That curve says that the conversion is slow. A typical parcel takes many tens of dynamical times to become starlight. Efficiency per free fall remains a few percent, a modest number that keeps the supply from vanishing and prevents wild surges. The curve steepens where bursts concentrate gas in compact rings and flattens where shear and pressure are gentle. Either way, the proportionality offers reassurance. Star formation is not a gambler's streak. It is a budget with regular income and measured expense. Self-regulation enforces the budget. As stars light up, they heat the gas through photoelectric emission from dust. They stir turbulence through winds. They elevate pressure through cosmic rays that spiral along magnetic lines and do not cool quickly. When the pressure rises, clouds resist further collapse, and the rate of formation falls. As the rate falls, pressure drops, and clouds again yield to their own pull. The system hovers near marginal stability, a calm edge where structure continually forms but the city never tumbles. The signature of this balance appears in the texture of the gas, a network of shells and filaments whose sizes follow a power law. Energy injected on many scales cascades to smaller ones until it dissipates, only to be reintroduced by fresh stars. Cosmic rays contribute a steady, unseen push that keeps the disk from compacting. Their gyrations deposit momentum over long distances, and their pressure helps launch fountains that lift gas a kiloparsec or more above the plane. The lifted gas cools, mixes with the halo, and falls back elsewhere. The fountain is not a storm, it is a weather pattern that trades parcels between heights. That trade replenishes outer regions with metals forged inside and spreads angular momentum through drifts that take hundreds of millions of years. In the meantime, the disk enjoys a slow convection that refreshes without erasing. Magnetic fields offer resistance without rigidity. They are strong enough to reduce fragmentation in the densest cores and weak enough to allow ambipolar drift, the slow slip of neutral gas through charged companions along the field lines. The slip grants gravity a path to win, but only after delay. The delay matters. It stretches the timeline of collapse and spreads star formation in time and space. The field also channels turbulence, shaping filaments that align with its direction in diffuse gas and switch to perpendicular in denser regions where gravity begins to dominate. The pattern is legible in polarization maps and starlight extinction, a script that speaks of guidance more than command. Not all star formation is clustered. The disk also hosts modest associations where only a handful of stars emerge before feedback clears the room. In such places, the imprint on the medium is a single bubble or a pair of arcs that fade with time. The stellar initial mass function, the distribution of newborn masses, appears remarkably similar from region to region within broad uncertainties. That sameness is another source of calm. It implies that the galaxy does not swing between extremes of dwarf-heavy and giant-heavy births. Instead, it produces a consistent mix, ensuring that heating, enrichment, and gentle stirring arrive in predictable proportions. Spiral patterns and bars organize the act without forcing it. As gas streams into a crest, it compresses and forms clouds. The crest moves on, and the new stars lag slightly behind, their light catching up as the gas already begins to disperse. The offsets along and across the arms read like a timeline: dust first, then glowing hydrogen, then blue clusters, then the aged yellow population. The order is tidy without being rigid. In rings fed by inflow toward the central region, the sequence wraps around a closed path, so that clusters age along an elegant oval. As they drift, they share their winds into a common reservoir that gently steams rather than boils. Cooling and heating lines keep the thermostat set. Carbon in ionized form and oxygen in neutral form radiate strongly at far infrared wavelengths when gas densities and temperatures land in the right ranges. Carbon monoxide and other molecules take over at higher densities, bleeding away energy until clouds settle to the low temperatures that favor core formation. Photoelectric heating from small grains responds to ultraviolet photons from young stars and raises temperatures in the diffuse phases. The two sides of the ledger match within factors of a few across vast areas, a result that would feel like fortune were it not the product of feedback loops recognizing themselves. Even where star formation pauses, chemistry continues its quiet work. Ices coat grains in the darkest cores. Ultraviolet photons liberated in rare flashes process those ices into organic molecules that later release when grains warm. The products seed the next generation of disks with compounds that can serve as the raw materials for atmospheres and oceans. On ladders of detail from kiloparsecs to microns, the medium makes future habitability a byproduct of present balance. He imagines standing within a tenuous shell around a fading H2 region, where the gas has cooled enough to allow molecules to return. The shell expands, slows, and ripples. In one ripple, a filament sharpens under the combined squeeze of curvature and pressure. Cores begin to appear along it, like dew beading on a wire at dawn. None of this makes noise to human ears. The pressure adjusts in whispering steps. The molecules tap energy away through photons that slip into space. The newborn stars open their eyes with light too gentle to reach skin. The scene is quiet because every agent has a way to release stress without tearing the stage. The largest comfort offered by gas and dust is their willingness to be patient. They do not rush to the last state allowed by gravity. They visit intermediate rooms, exchange energy with radiation and particles, accept the counsel of magnetic fields, and emerge with structures that favor longevity over spectacle. Because of that patience, the galaxy maintains a steady glow rather than a strobe. The lanes remain recognizable. The supply never arrives as a flood or dries to a drought. The physics that could, in theory, drive extremes here conspires to moderate them. He lets that thought rest like a stone at the bottom of a clear stream. Above it, ripples run, flakes of light twirl, tiny eddies tug and release. Yet the stone is undisturbed. The interstellar medium behaves in much the same way. Energy pours in and drains away across scales, but the larger form persists. Calm is not a mask over turmoil. It is the emergent face of a system that has learned to distribute its restlessness so evenly that rest becomes the impression. In that impression, a listener can finally breathe with the galaxy, long and slow. He opens a watch and finds not gears but gravities. Time in a galaxy wears many faces, and each face measures a different kind of quiet. The simplest is the orbital period, the time a typical star needs to circle once around the center along its nearly circular path. Near a radius like the Sun's, this loop takes a few 100 million years. In closer lanes, the period shortens. Farther out, it lengthens. The meanings accumulate. A single orbit carries climates across spiral crests and lulls, while a handful of orbits are enough to spread memory through phase mixing and turn sharp features into smooth gradients. The sweep of a hand on this cosmic dial is too slow for human eyes, yet its constancy steadies the city of stars. Another interval sets the beat for small adjustments. The dynamical time measures how long gravity needs to move matter significantly within a region of given density. In dense neighborhoods near the center, it can be a few million years, allowing gas to respond briskly and star clusters to reshape quickly if they must. In the outskirts, where density is low, the same measure stretches to hundreds of millions of years. This stretch explains why disturbances in the halo look like distant swells rather than breaking waves. A low-density field carries ripples that take their time to reach shore. Epicyclic periods layer a softer rhythm on top of the main orbit. A star wobbles in and out and bobs above and below the plane, tracing small loops around a guiding circle. The radial epicycle completes its circuit in less time than the full azimuthal loop. The vertical bounce cycles at a rate set by the local restoring force toward the midline. These two clocks tell how quickly a star samples the gradient of the disk and the thinness of the plane. They keep nearby neighbors in gentle conversation, returning each to familiar longitudes and heights, often enough that encounters remain rare and the overall texture maintains a satin calm. Relaxation by many small gravitational tugs has its own astonishing calendar. In a sparse disk with vast separations, the time for random stellar encounters to change velocities appreciably exceeds the age of the universe. The calculation is a comfort. It says that the order seen in kinematics is protected from the roughness of crowding. Encounters matter in dense clusters where stars brush within tenths of a parsec. They matter little in the open lanes of a galactic disk. Where relaxation is endless, serenity follows. Secular evolution deserves a long calendar of its own. Bars, spirals, warps, and bending waves reshape distributions, not in cycles of thousands of years, but in spans of hundreds of millions to a few billions. Each pattern marches to a pattern speed that sets where resonances live and how angular momentum flows. A bar can lengthen by trading with the halo over eons, its corrotation creeping outward like shade across an afternoon courtyard. Spirals can renew as self-excited modes that last for a few rotations, then hand their place to successors with slightly different phase. The slow transfer of angular momentum through resonances at corrotation and Lindblad radii is a conveyor that runs with a whisper. Time here is not a line of ticks. It is a slope that one steps down without noticing. Gas introduces clocks that feel like breathing. Cooling times in dense molecular cores can fall below 1,000,000 years, a blink compared with a rotation, allowing temperature to drop and collapse to begin. The free-fall times of those cores are only a little longer, yet feedback stretches the act. Outflows and radiation from newborn stars add pressure that lengthens collapse by factors of several. On cloud scales, the lifetime extends to tens of millions of years. On arm scales, the sequence from dust lane to bright cluster to dispersed association plays out over tens of millions more as the pattern slides past. Self-regulation ties these clocks to one another. When star formation rises, heating and turbulence shorten the lifetimes of dense pockets and lengthen the intervals between the next sparks. When star formation falls, cooling and gravity shorten the pauses. Balance emerges from clocks that read each other. Chemical evolution writes dates in light elements and iron. Alpha elements arrive quickly from massive star deaths, while iron from type Ia supernovae trickles in on time delays that range from a few 100 million years to several billion. The ratio of these elements becomes a stamped record of the pace at which a population formed. A high alpha signature marks a brief, intense epoch in which the early deaths dominated before the late iron arrived. A low alpha imprint marks a broad, leisurely epoch where delayed enrichment had time to accumulate. The galaxy holds both signatures, and the times in between appear as smooth slopes on diagrams that compare abundance ratios. Those slopes are calendars read by spectrographs. Cosmic rays drift on their own timetable, streaming along magnetic fields and scattering off irregularities in the plasma. Their residence time in the disk spans millions to tens of millions of years, long enough to distribute pressure gently and heat gas without insisting on proximity to the sources that accelerated them. That persistence adds a cushion to the interstellar medium, a slowly varying background that resists sudden collapses and moderates sudden surges. Where photons dump energy quickly and leave, cosmic rays remain to keep the thermostat from wandering. Inflow and outflow exchange fuel with the halo on still longer schedules. Gas lifted by fountains cools and returns over hundreds of millions of years. Streams stripped from satellites thread the outskirts and reach the disk after similar spans. The hot circumgalactic medium cools only reluctantly, with times measured in billions of years at low densities. These long clocks prevent the disk from feasting or starving abruptly. Supply arrives as drizzle rather than downpour. The drizzle feeds arms, rings and bars at rates that digest rather than gorge. Dynamical friction adds a deep bass note. Massive bodies such as star clusters or satellite galaxies plow through a sea of lighter particles and raise wakes that tug backward. The timescale for this drag to shrink orbits depends on mass, density, and speed. For a small satellite in the outer halo, the time can exceed a Hubble age, leaving it to wander as a companion. For a more massive body plunging deeper, the time contracts to a few billions of years, enough to drive a slow in-spiral that breaks apart the visitor and mixes its contents into the host. The kindness of these spans is that they spread the energy of encounter across immense volumes, blunting what might otherwise be felt as shock. Star clusters evaporate on clocks that reflect their binding energy and encounters with the tidal field. Open clusters dissolve over hundreds of millions of years as members drift away. A tougher handful survive for longer. Globular clusters resist for billions, yet even they lose stars at a rate that carves thin tails along their orbits. These tails remain coherent on their own mix of timescales, stretching slowly until they become part of the background. Evaporation and stretching write poetry in patience. No stanza ends abruptly. Each line lengthens until it merges with silence. Planetary systems carry delicate calendars within the broader one. Debris disks grind down as collisions turn boulders into dust over tens to hundreds of millions of years. Migration of giant planets settles early, often within the first few million years of a system's life, while terrestrial worlds complete their assembly on times closer to 100 million. The quiet surrounding a star in a modest neighborhood allows these processes to play out without frequent external interruption. A wide spacing between stars means that planetary clocks can keep time undisturbed. Life, if it emerges, inherits the long hour hand. Warps and bending waves precess with such elongated periods that they appear frozen to short-lived observers. A global tilt can take 1 billion years to turn its node around the center. Corrugations nearer in can have shorter cycles, yet still long enough to require patience to detect change. The disk's vertical memory, therefore, reads like a set of slow oscillations superposed on the steady spin, a superposition that deepens perspective without threatening balance. Even light carries a clock in this setting. Photons born in dusty nurseries wander through grains, scattering and absorbing, before escaping in the infrared as a gentle warmth. The path lengthens with optical depth, and the time to leave grows from microseconds to far longer according to the thickness of the veil. On galactic scales, the delay is small, yet the cumulative effect is perceptible in how star-forming regions glow at wavelengths that announce energy released slowly. Heat leaks away with decorum. There are clocks that measure forgetting. Phase mixing erases clumps in angle space on a few orbital periods. Chaotic zones in action space diffuse on times that depend on the depth of overlap between resonances. Regular zones retain sharp edges for far longer. The distribution of stars with similar actions remains crisp, because those actions change only under perturbations that act for ages. A map of these features is a stratified record. Recent nudges write spirals and folds. Ancient events write broad gradients. Both keep their place for as long as their timers allow. Instruments that read these clocks improve step by step. Proper motions pin down periods. Spectra decode nucleosynthetic delays. Radio lines trace the freefall. X-rays weigh the hot delays in the halo. The convergence of all these hands on the same face of the watch confirms the theme. A galaxy maintains its calm by spreading change across times that rarely collide. Fast processes end before they can disrupt their neighborhoods. Slow processes take so long that each neighborhood adapts as they proceed. The tension between quick and slow is not a conflict. It is a truce negotiated by physics. He imagines placing his palm on the disk and feeling several pulses at once, the rapid flutter of cooling in a core, the steady beat of epicycles, the slower throb of orbital return, the nearly sleeping rise and fall of a warp. The pulses overlap into a hum that never jars because none demands the whole stage. That is the gift of many clocks. Each keeps peace by claiming only a fraction of attention. Together, they build a continuity that feels like rest. He surveys the instruments that turn night into numbers and finds serenity in their patience. An orbiting observatory measures angles so small they feel like thoughts. Its detectors watch a billion points drift against the far background, fixing positions and motions with micro-arc-second care. From those motions come rivers in the plane of the sky, spirals in velocity space, and a six-dimensional map of the disk that shows ripples as clearly as rain rings on a lake. Astrometry becomes the first calm art, a geometry of trust that turns starlight into trajectories. Spectroscopy adds the second art by teaching light to confess its composition and speed. Fiber-fed telescopes gather thousands of stars at once, spreading their colors into coded bands where iron, magnesium, and oxygen leave soft imprints. A single visit yields a radial velocity and a suite of elemental ratios that read like birth certificates. Repeated visits tighten the speeds and reveal binaries that would otherwise hide. The marriage of position, motion, and chemistry allows stars to be grouped by shared origins and shared paths. Chaos loses ground when identities become clear. Astroseismology listens deeper. Spacecraft that once chased exoplanet shadows have left a second gift. Flickers across a star's face betray pressure waves in its interior. From those patterns, densities and ages can be inferred with a precision that feels like volume turned down on uncertainty. Combine those ages with kinematics, and an evolutionary clock appears that tracks how dispersions grow and how migrations proceed. The quiet deepens when time itself is measured from within. Radio work maps the skeleton of gas. Antennas tuned to the hydrogen line sweep the plane and reveal a disk drawn not in light, but in spin flips of electrons. The line slips through dust without difficulty, so it traces spiral lanes where optical images would go dark. Molecule hunters shift to lower frequencies to catch carbon monoxide and its kin, markers of cold clouds ready for birth. Interferometers gather dishes into synthetic apertures that sketch lanes with the clarity of ink on rice paper. At the cores of some clouds brighten pinpoints where masers light up. Very long baseline networks measure their proper motions and parallaxes, yielding distances and pattern flows that anchor the arm geometry with ruler-like assurance. Polarization reveals the invisible hand of magnetic fields. Dust grains align and scatter light with a preferred orientation. Radio emission from cosmic ray electrons spirals along field lines and arrives polarized. Maps of these orientations stitch a fabric over the disk, showing where fields bend and where they run straight. The lines are not iron bars, they are silk threads that guide and delay, and the maps quantify that guidance. When the field is known, the pressure budget of the interstellar medium is known more fully. Balance becomes something that can be calculated, not guessed. Infrared surveys paint the older stellar population with warmth instead of glare. Near-infrared light slips past the veil that dims the core, revealing the elongated lantern of the bar and the X-shaped swelling of the bulge. Mid-infrared maps pick out dust heated by gentler stars as well as by newborns, turning the plane into a sequence of rings and spurs that trace resonances. Far-infrared instruments find carbon and oxygen cooling lines that act like thermostats. Each wavelength offers a separate layer of the same calm atlas. Together they collapse ambiguity. X-rays open the halo. A soft glow spread over the sky comes from gas at a few million degrees, and spectrometers measure its temperature and chemical content. The sight lines toward background quasars serve as needles that sample the hot medium through absorption lines. The needlework shows metals distributed far from the disk, evidence of fountains and winds that left but did not run away. Knowing the pressure and extent of this corona allows models to set the boundary conditions that keep the outer disk from feeling sharp drafts. The breeze is quantified. Microlensing watches the crowded heart for brief brightenings when an unseen mass crosses the line of sight. Each event is a lensing fingerprint that depends on mass and motion rather than light. Thousands of such fingerprints measure the mass function of faint stars and remnants in the bulge and constrain how much of the unseen could be compact bodies. The answer favors a diffuse background for the missing mass. The method works by monitoring and patience, a discipline that suits the tone of a galaxy that does not rush. Pulsar timing adds a metronome that rivals any clock on Earth. Millisecond pulsars across the disk and halo keep time so accurately that variations in their ticks reveal disturbances in spacetime and in the electron-filled medium between stars. The delays trace the weather of the interstellar plasma along each sight line. Rings and ripples in the dispersion measure can reveal large-scale structures long before images resolve them. The clocks also test gravity near a central mass when orbits carry a pulsar close to the core. Every successful prediction from the theory of relativity removes another invitation to drama and replaces it with faith in calculation. Gravitational imaging of the innermost shadow has become a portrait rather than a rumor. Arrays spread across continents catch radio waves that circle the event horizon before they escape, producing a ring whose diameter reveals mass directly. Variability during observations blurs details, yet pattern matching across many sessions yields a consistent silhouette. The portrait calms arguments because it is purely geometric, a picture drawn by light, taking the only paths available in a curved spacetime. Time domain surveys look for change and mostly find repetition softened by noise. Variables, transients, and moving objects populate catalogues that update nightly. Cepheids and RR Lyrae provide distance yardsticks that refine the scale of the disk and halo. Long-period variables trace old populations. Novae flare and fade without disturbing their neighborhoods. The cadence of observations sets the cadence of discovery, and when the cadence is steady, the discoveries reveal a galaxy that keeps tempo. Numerical experiments transform theory into tangible weather maps. Codes that integrate gravity and hydrodynamics evolve disks inside halos, while stars form and die within them. Feedback is tuned to match observed relations between gas and starlight, not as an act of convenience, but as a way to fold known physics into the experiment. When synthetic galaxies grow bars and spirals with realistic pattern speeds, when they thicken at the right rate and show rings at the right radii, confidence grows that the equations capture the essence. The goal is not a perfect copy. It is a family resemblance strong enough to explain why order persists. Orbit modeling uses action angle coordinates to fit distribution functions to real data. The fits produce potentials that support the observed shapes and motions. Sculpted models of the bar with pattern speed as a parameter are compared to star counts and gas flows until a narrow range remains. Spiral modes are recovered by decomposing maps into Fourier components and measuring phases. Warps are described by bending mode theory and constrained by vertical proper motions from astrometry. Each analysis reduces possibilities to a corridor in which the system lives comfortably. Uncertainty narrows without vanishing, like a river channeled but still free. Machine learning plays the quiet role of librarian. Algorithms sift through billions of measurements to find streams, moving groups, and rare stars with peculiar chemistry. An outlier flagged by a model trained on the majority can become a new clue to a past merger or a new test of nucleosynthesis. The method accelerates discovery without changing the tone. It does not invent structures. It recovers them, then hands them to human judgment for interpretation. Calibration sustains trust. Parallaxes set the bottom rung of the distance ladder. Standard candles lift it outward. Cross-checks between techniques catch biases before they harden. Telescopes observe the same fields from different platforms to reconcile 0 points in brightness and color. Spectroscopic pipelines compare derived temperatures and gravities against stars with interferometrically measured diameters. The effort feels like tuning an orchestra before a long performance. When tuning is careful, the symphony that follows reaches listeners without strain. Vision continues to extend. Larger mirrors and colder detectors promise sharper maps of dust and gas. New radio arrays will catch fainter mazes and trace flows at greater distances. X-ray spectrometers with higher resolution will separate lines in the hot halo and measure turbulence directly. A space-based gravitational wave observatory will listen for compact pairs in the central parsec and weigh the spin of the dark heart by timing its whispers. Each promise is modest in tone because it seeks clarity, not fireworks. What these tools achieve together is a translation of awe into measurement. By plotting motions, fitting potentials, counting elements, and watching variability, they test the idea that a galaxy can be both active and restful. The tests return similar answers across methods. Rotation is flat over a wide span. Pattern speeds sit within narrow ranges. Dispersions grow with age gently, not wildly. Rings align with resonances that theory predicts. Streams curve where an extended halo would draw them. Gas forms stars at a rate proportional to its mass and regulated by feedback. The convergence is not a chorus of certainty, but it is a harmony that invites sleep. He imagines a control room lined with screens that update in real time. One shows proper motion vectors like threads on a loom. Another shows spectra as forests of lines. A third renders a simulation moving an hour for every million years. In that room, the galaxy appears not as a blur, but as a system whose calm can be demonstrated. The proof is not a single figure. It is a patient accumulation of small agreements that leave little room for alarm. He breathes with the instruments and feels the hush they quantify. He follows the starlight until it thins into breath, and the breath into near silence. The bright disk gives way to sparse traces, and those traces give way to a geometry without obvious landmarks. In this reach, the notion of an edge becomes a matter of choice. One may choose a radius, where the average density inside matches a fixed multiple of the cosmic mean. One may choose the farthest apicenters of bound travelers as a practical border. One may choose the distance where a gentle escape curve dips below a given speed. Each choice sketches a different shoreline on the same dark sea, and each shoreline is a gradient more than a line. A walker of orbits would feel that softness step by step. Speeds decline with radius, not in a cliff, but in a slope that stretches for hundreds of kiloparsecs. The gravitational well eases, the sky grows wider, and time between pericenters lengthens from centuries of cities to the durations of continents. Where streams turn back, the turning is unhurried. Where satellites bend, the bend grips more loosely. The halo does not snap shut. It invites, and then it requests that each visitor declare a loyalty by its energy rather than by a sign at a fence. There is a surface where expansion pauses. The surrounding universe continues to drift apart, carried on the general flow of space. But there exists a region where the pull of the galaxy and its nearest companions counters that drift. Far out from the luminous disk, the velocity relative to the whole cosmic tide becomes zero. Inside that surface, motions tend to return. Outside, they tend to join the broader migration. The shape is not a perfect sphere, because neighbors and filaments pull from different directions. The notion calms by virtue of its clarity. Belonging is measured by which way time moves, inward or out. Near this gentle boundary, matter does not gather into sharp ridges. It feathered there over epochs, drawn along the filaments of the web, and then slowed by the swelling gravity of the combined halo. Some particles overshot and returned, laying down a faint splash of density that waves through the outskirts like the furthest ripple on a lake. The wave is most visible in models and in populations of scattered tracers whose distances and speeds have been tracked with care. What the image conveys is restraint. Growth ended not with a bang, but with diminishing returns. The hot atmosphere extends to meet the dark scaffold in a compromise between pressure and pull. It is too thin to see by eye and too warm to settle quickly. Metals born in the disk have ridden out on fountains and winds, and a portion now resides in this envelope. Its presence gives satellites a medium to lean upon, stripping them of gas as they pass, and preventing fresh arrivals from lighting bright fires too easily. The effect of this cushion is to soften both entry and exit. New fuel does not crash. Old memory does not flee. Streams in this margin wind into their final arcs. Their cold widths broaden slowly as they phase mix, their once crisp edges dissolving into a fine lace that instruments can still trace if they look closely. Occasional gaps interrupt the ribbons where unseen subhalos once crossed, and the spacing of those gaps says something about the secret population of lumps that never shone. Yet even the interruptions feel like edits rather than erasures. The text of the stream remains legible as it fades. Satellites that have not yet committed to surrender or escape use this space as a waiting room. They wheel about on paths that may take a Hubble time to complete. Some carry their own attendants, small clusters, and even smaller companions, a nested dance of gravities negotiating for a center. The larger pair that shares this sky writes a baseline under the halo, slow and persistent, drawing tides that tilt the far gas a few degrees from the inner plane. The tilt precesses so slowly that the whole arrangement looks like a frozen nod, respectful rather than strained. Light from beyond comes through this periphery with almost no obstruction. Background galaxies and quasars provide needles for measuring the temperature and turbulence of the thin plasma. Their spectra wear narrow notches where ions in the halo absorbed particular wavelengths. The notches say the gas is warm but not wild, enriched but not heavy, extended but not wasteful. The knowledge that the halo's veil is both real and transparent adds reassurance. What is restful is often what does not demand attention. Gravity at this distance remains faithful to accounting even when catalysts are few. The acceleration is small, yet cumulative. A star at the far turn of its path lingers for a disproportionate share of its time near apocenter. From that high perch, the galaxy below appears compact, a coin of light set in black felt. The scouting eye could pick out the bar as a soft bar of glow, arms as pale swaths, and warps as a lifted rim. The rest is emptiness of a kind that is not empty, because every direction holds a faint pull from thread-like structures that knit the larger cluster of groups and clusters. The coin rests inside a basin, and the basin drains toward a greater confluence. The feeling is navigation rather than confinement. There are travelers whose energy places them at the balance point. A small nudge outward, and they would be lost to the group. A small nudge inward, and they would descend. These bodies, whether stars ejected by multibody dances in the core or dwarfs slung by mutual shoves, write delicate lines through the borderland. They are rare and therefore precious. Like seeds carried on high wind, they test the fertility of the desert. Most will not plant. A few will, in other times and places where the field is deeper. What listens here is not only matter, but also light's memory of beginnings. The microwave background streams through, its pattern minutely warmer in the direction the local patch is moving, minutely cooler opposite, a dipole etched upon the whole sky. From near the edge of the halo, that dipole reads as a story of larger currents. It says that the entire basin is drifting toward a deeper valley beyond the map drawn by stars. It says that the calm seen locally is part of a vaster flow whose timescale is too long to trouble the present. The future of this border is written in slow ink. Fresh infall will be meager. The main growth has finished. What remains is the smoothing of what arrived, the settling of orbits to their gentle loops, the gradual fading of thin streams into a continuous halo. Meanwhile, the bright disk continues its errands, turning gas into stars and returning a fraction to the hot envelope in a cycle that shrinks only as fuel diminishes. Nothing in this forecast looks abrupt. The last acts of a spiral galaxy are quiet acts. He imagines one last survey, a patient drift outward along a line that leaves the plane at a shallow angle and heads toward the faint line where belonging fades. The disk dwindles. The halo resolves into points, and then into darkness with arithmetic underneath. The final tracer that still holds the name of home swings and begins the return. Beyond that, the field accepts no pledge. There, the universe is a lower density sea, where the only law that gathers is the sum of distant islands. He pauses at that imagined perch and realizes that calm grows with perspective because gradients soften and promises slow. The edge is not a place of warning, it is a place of understanding. Night gathers its patient silk across the roof of the world, and the river of stars lies like frost on black stone. A listener could stand very still and hear, not with ears but with the deep drum of the chest, how a city of suns arranges itself into kindness. Inward, a compact heart keeps time by curving space into steady vows. Outward, A scaffold without light holds the cup of the sky without spilling. Between them, dust cools bright tempers and gas remembers to breathe. Orbits fold and unfold, like hands at rest. Nothing hurries and nothing is late. A human life is a spark, brushed from that long wheel. It is brief and hot and full of errands, yet it learns by looking up. It learns that order is made, not declared. It learns that violence can be distributed until it becomes weather. It learns that patience can be structural. The long corridors of the disk and the wide parishes of the halo make a sanctuary where chance can try its instruments without fear of a shout. Planets turn, oceans cool, minds rise and ask. He closes his eyes and the dark keeps its figures. Ratios hum where voices end. A spiral is a rule written in moving light. A bar is a spine that knows its burden. A stream is a sentence that chose the long way home. When dawn erases the band from the sky, the facts remain, tucked into stones and blood and the slow calendars of trees. The Milky Way stays above the day like a quiet vow. Somewhere beyond the glare, a coin of grey still shines. Somewhere beneath the glare, a heart keeps time. The rest is breath. End of script.